A very good afternoon to everyone. I take the pleasure of inviting you all to the day 6 of ATAL Online Faculty Development Program on Advanced Computing and its application trends. Now I would like to call upon Roja Priscilla Madam, Assistant Professor, Department of Computer Science, to introduce our session speaker. Over to you.
Okay, sir. Good afternoon, one and all. Myself, Roja Priscilla, faculty member from the Department of Computer Science, PBSC, takes the privilege of introducing today's resource person, Mr. Prakash Kacha. Prakash Kacha holds an MCA in Computer Applications from Jawaharlal Nehru Technological University and a BSc in Mathematics, Physics and Chemistry from Satavahana Degree College. With 25 plus years of experience in technology leadership, Prakash has built a career spanning networking, embedded systems, IoT, AI/ML, and telecom domains. As a co-founder and CTO of Sadruso Technology Ventures, he has driven innovation in content as a service, low-code, no-code platforms, and smart utilities for the electricity transmission sector. His work extends into IoT solutions for pollution monitoring, healthcare, and smart appliances. Previously, he co-founded CoolTalk, a VoIP-based communication startup, which was successfully acquired by Kirusa, where he later contributed as a technical solution architect. Earlier roles at Motorola, Nokia, Symbol Technologies, One Access Networks, and Mistral Solutions saw him deliver key innovations in network management systems, device drivers, hypervisors, RTOS, and AI-driven solutions. He is also a patent holder, author of thought leadership blogs on IoT and AI/ML, and an active mentor for cross-functional engineering teams. Prakash continues to align technology strategy with business growth, bridging embedded technology, AI, and enterprise solutions, bringing board-level value as an entrepreneurial CTO with proven startup success. A hearty welcome to the FDP, sir. You may now take over the session.
Thank you for the warm welcome and onboarding, madam.
Oh, welcome, sir. Thank you.
So, just to continue with what madam has said, I'll just give a small brief about myself before I see everybody coming on board here. Give me a second so that I can mute my phones. Most important thing. Okay. Done this just before the startup. Yeah, coming back to this thing, before we wait for others to join, I just want to take another 5 minutes of time to just give a brief, a little more elaborate intro about me, what I have done, so that will set the tone and context for the discussion. And then I have also, that will give a lead into how these technologies have evolved over a period of time, and what is that we are looking at supercomputing and all these things. So I started my career as a small programmer in one of the government organizations called Research Center Imarat RCI. That was for a very brief time where I worked on some real-time systems and one small application program developed for one of the weapons that they were building. And from there, I moved on to a startup company called Mistral. And then from there, we were developing a lot of board support packages, building device drivers on VXWorks operating system, which was a very crazy skill to know those days. This I'm talking about way back in 1998. And then from there, subsequently, I moved to the company, small startup called Ramp Networks, where we were building routers, small office, home office routers. And then I was helping, I was a junior engineer then, so I was developing a lot of this code for the device management software. And from there, I moved on to that company got acquired by Nokia. And then I was there for a little long time there. And then we were building a lot of checkpoint-based IPsec VPN solutions and device management and network management solutions. Subsequently, from Nokia, I moved on to another startup company called Symbol Technologies. There I worked for 2 years building a RMI XLR 732 based processor based routers, which can go as a line cards. So we worked there. I worked there for a couple of years, and then subsequently that company got acquired by Motorola. So I was there for a couple of maybe a year or so at Motorola, all 3 years put together, and then subsequently I moved to another startup, which was more promising those days. It was on virtualization, because that's when in 2008 a lot of companies started getting into this IO virtualization, storage IO, all these things like building a hypervisor on KMO, what we call the VM player and VMware, those open source solutions. We were working on the open source solutions part of that. So I was there for a year or so there, and then subsequently I moved into another networking company called One Access. So that got acquired by Equinox. And then we were building small office, home office routers for the France Telecom and Deutsche Telekom. So all through my career, I was working mostly on the operating system side, building applications and interfacing the applications, IPsec stack and all these things with the OS. So we were doing a lot of things with respect to virtualization, kernel, and all those things. So subsequently in 2013, I decided to hang up my boots, and then I said, enough of working for someone else. Let me start my own company. And then me and along with my classmate from school, we both started a company called Cool Talk. The idea is to build a VoIP solution where the trigger is your GSM call, but the entire call gets converted into a voice over IP. This was a unique proposition, and then we had a patent for that. That is the same patent that now in all your mobile phones you have this calling via Wi-Fi, right? That is actually a patent that we developed in 2013, and then subsequently for that patent and then the product, we got acquired at a very early stage by a company called Kirusa. Subsequently, Kirusa also got acquired by Gupshup, and then a couple of those patents were taken over by some of the biggies. So it is a very interesting journey for me. And from there, I moved out of from the acquirer, and then I moved to another company called Personal Air Quality Systems, where I was part of, I was the CTO, and I was managing the product development of pollution monitoring. So we developed a pollution monitoring device that got into this smart cities. So one of the biggest smartest cities that we did, the project that we did is for Vizag Smart City. All the 56 sensors that are placed around the city are given by my company. And then subsequently we did for Jaipur, Varanasi, Nagpur, Pune, on total around 22 cities. We have done this. And there from subsequently I moved out of that space, and then that was getting saturated. And then I moved into more so-called that day trend was content management systems and content as a service. So we built a couple of products there, but we didn't see any great luck with it. We just bailed out. We just got bailed out and barely were able to handle it. And then from there, we were looking for new opportunities. And one of the big opportunity that we saw is in the space of AI and data. But everybody talks about AI and data. To be honest, I have not seen one big company which has actually made money on AI till now. Yes, we have a lot of ChatGPT based applications that give us various things to make PPTs or to make content or to write our reports and all those things. But technically, we are yet to see one huge disruption that caused by AI. So coming back to the AI part, and then when we started getting into the AI, eventually we saw a lot of Application related things are pretty common there, which is not really that kind of a rocket science. But the whole AI part has a lot of very interesting things that are happening at a infrastructure level. So you need good infrastructure to run an AI model. And then what are the needs of these AI models? And how do we identify the infrastructure for that? So that curiosity in me, those questions have built a lot of curiosity for me. And then with that curiosity, I started understanding various things in this computing. So a couple of interesting things because of my previous work experience with virtualization and then getting into the computing part. So we figured out some interesting solutions, both as a hardware from the hardware perspective and from the application perspective. And then how do we customize these kernels? How do we handle these data? So these are all the questions that we have. And so what I tried to do is when I was requested to give this presentation, I tried to bring a lot of thought process, and then I have collated one small PPT presentation so that I can just give at least touch a surface, scratch the surface of this supercomputing, and then see let's how much I can cover in this session. So let me just. Can you make me a host so that I can share? I think I can share. Interesting. I hope you can see my screen.
Yes, sir.
Yeah, thanks. So in a very nutshell, if I want to go ahead with, let's start with a very basic thing. We all know what is computing. We have been studying from our school days. Probably the new generation would have studied from the school days. I started studying it right from my college days. What is a CPU, arithmetic, what is an ALU, what is a RAM, what is a processing, what is a storage, and what is an output. So input output devices and all these things. So this is a basic part of the computing. So anything that you have to process and inform a data. So one is collecting of the data, which is the very critical part of it. And once you collect the data, and then you convert the data into information. So how do you that entire conversion of the data into an useful information is what is a processing. And then you use certain algorithms to do the processing, and then you get the required information. So this is at a very fundamental level. This is the basic of computing, which you all know. And then this fundamental is not going to change anywhere. All that is going to change, or all that is changing over a period of time, is the method in which you apply this. So the algorithm doesn't change of processing a data, and your input devices will be more now. Previously, we used to have a keyboard and a mouse. Not sure how many of you know at a certain point of time when I was in the college, we were taught directly on Linux. Not Linux. Linux was also not there. It was SCO Unix, and we used to have SCO Unix and FreeBSD. So other than keyboard, we don't have anything. So everything is keyboard based. Your text processing, everything we used to use VI editor and then go ahead with that. So the input devices was only a keyboard. But now when I see the whole computing gamut, we have keyboards, mouses, these stylus pens and all those things, and plus the sensors which directly give the data. And then there are various other touchscreen things that are coming up. So the input is coming from multiple sources. So as and when we progress with innovation, we see a lot of input devices coming in. Similarly, we have seen the storage also. Like when I started having a 2 GB RAM and a 4 GB hard disk was a big thing. So like when I was promoted from a software engineer to senior software engineer, my PC got upgraded to 4 GB RAM and 8 GB hard disk. So I felt very great about it. Like my computer has got 4 GB RAM. Now in a mobile phone, you are having a 4 GB RAM. So these are the things that have changed over a period of time. So this is something that you all know. So now the storage has increased your RAM, SRAMs, and your hard disks. Now the hard disk from IDE to SATA to SSD. So things have changed in a big way. And then coming to the output, so the displays also. You all, I mean, now the same computer can be connected to multiple displays, not just a monitor or just a simple single color monitors. Now we are having a display with a lot of what do you call, all the graphic things with gaming and everything coming out. So multiple outputs are coming up from the same processing of the application. So now once we see, this is what we have seen from a basic thing of what is computing with single input processing, storage and output, to we are slowly seeing what is called as supercomputing. So supercomputing does not change the basics of the computing. It is still the same computing that we are using, but what we are doing differently. We are not doing different things. We are doing the same thing, but we are doing those things slightly in a different manner. So basically the power of the computer has gone up. So from x86 processors like 386, 486 and 586 to Pentium, from Pentium to i3, i3 to i5 and i7. Probably we are seeing i9s, and then also AMD's R series and all these things. So the processing power of the CPUs have gone up exorbitantly, and then the size of the CPUs have come down. And then that is like sitting on a small devices like your mobile phones, like Snapdragon from Qualcomm or from Intel, sitting on a laptop, which is like a wafer thin laptops are being created with a very wafer thin processing CPUs. So, and with a large computation. I mean, the idea is where we used to have is very less IOPS and then flops. Now we have much bigger flops happening in the CPUs. So your computing has gone up. So technically from the supercomputing is just a next level of computing which can handle large computations at a scale. So previously, like I used to give one instruction, the CPU has a certain ability to process in a given time. So it processes that and then gives it back. And then that logic is stored. And then again, I go back, give the next instruction, it executes. And then, so it is all in a pipeline mode that is doing. But over a period of time, what happened is when the supercomputers started, we started thinking about the parallel computing and all those things, when it came into picture, now your CPUs have become powerful. It does not take just one at a time. It can take multiple things at a time and then parallelly process all these things, and then there will be a control thread. So then we started getting into this concept of threads. So threads is not about the operating system threads that I'm talking about. Here I am talking about the hardware threads. So in the hardware, basically when you have a multi-core, so you call it one as a control core, control thread, and then remaining all the other cores are your processing threads. So basically the control thread decides which particular application or which particular computation instruction, maybe at a computer level we will say, and which instruction will be executed on which particular thread. So this has been a continuous thing that is happening. And then I saw from like a 4-core processing to a 8-core to a 16-core to a 32-core or a 256-core. So we keep incrementing these things so that those small cores do small amount of work, and then all these small amount of work are like combined together and then put into one single output, and then from there we combine them and then give it as a next big output. So supercomputing is still the fundamental didn't change, but it is only how quickly you can do it and how parallelly you can do it. And then suppose even if you are doing a very small work, right? Previously, as we gain experience, we can do, even in our regular household, we do a lot of things parallelly. Like previously, I mean, I'll take just a funny example. Previously, we used to only drive cars. Then the audio system came into the car. So you are listening to the songs and then you are driving. And then you are parallelly changing the car songs, and then you are listening to the songs and then you are driving. And then now you have a phone call, mobile phone that has come and then got connected to the mobile phone is there. You put it on speaker and you're talking. Then you are connecting it to the Bluetooth and you're talking and driving. So basically, you are doing many things parallelly. Now your cars have started getting more and more features, and then you have much bigger activities that you can do parallelly. So the same is applicable here in supercomputing also. How do we parallelize all these instructions and then execute something fast? So it is not just fast. Okay. So fast is one part of it. What difference it makes when I have to add 1 + 1 is equal to 2? Whether it is a normal computing or a supercomputing, it doesn't make any difference because it is only one instruction set that you are giving it. Now, the whole story changes when you are thinking about complex applications like audio, video. Those are also because your regular CPUs have become more powerful, so you are able to handle that. Now, what are the supercomputing things that you can do? So slowly we started getting into processing huge data sets. That is the biggest application that we ever saw. As in we started digitizing the whole workforce or whatever we call, more and more digital data coming in. Now you need to parallelly process all this data and then give some real-time information. One small example that I would take is electricity, which is a very favorite topic for me also nowadays. So you have these substations where a lot of power keeps coming from various transmission lines into the substation. When the power comes into the substation, it just get distributed across various feeders, and then it goes out for the final distribution to the commercial usage, like to the homes or to the malls or to the apartment complex and all that. So there is a computing that is required to identify all these data points, continuously monitor the real-time activity, which is the substation monitoring application. So this has to identify the change of power, the frequency of the power, or any of these small things at a super jet speed. So, but there will be a lot of data that will be coming in. So all these things are possible only when you have a supercomputer kind of a computing application that is ready for it. So now when I have to run this kind of applications, like suppose the power is coming, it is coming from a transmission line, it came to the substation. From substation, I put a transformer and then I reduce from 66 kV, I reduce it to 33 kV or to 11 kV and then give it to a feeder. The 11 kV feeder goes out and then gives the power to the houses. So this is a very simple transmission network they have built. But now in my substation, when I am sitting and then monitoring this entire activity, there can be various factors which will affect the transmission of the power. It can be the environment that is in which, because it is an open yard, your humidity, your temperature levels, because to keep the coolant, you put some kind of a oil level management. So there are like 15 to 20 parameters which have to be computed at the same time, and then also look at the power and then combine all these parameters together and say that, compute all these parameters together and say that, hey, your substation is running fine. There is no issue at this juncture. At this instance, there is no issue. But that may change second to second. Suppose there is a load, peak load that comes from the usage. Somebody in the village has suddenly started drawing more power by putting a couple of generators or a couple of air conditioning machines. So then the load goes up. then accordingly your other factors will change. So to monitor these things, take some few parameters at a time, and then periodically in real time when they have to compute and give those values outright, your existing computation systems are not adequate. So that's why you need a high performance systems. So that is where one of the biggest application of supercomputing. So I'm not just talking about the hardware part here. I'm also talking about various applications that are part of this supercomputing. I hope everybody is with me, and I know it is post-lunch session. So if you guys have anything anywhere, right, just stop me and then ask your questions. Let's make it more conversation, because after 2 p.m., conversational presentation will be much more fruitful rather than a one-sided talk. Yeah. So one of the main thing that you need to understand in supercomputing is the flops. So let me just go to a very small slide on this. So floating point operations per second, this is the flops, and then this is the one that defines the power of the supercomputer. So these are very simple things like T flops, P flops, and E flops. These are all the things that are coming up. So now, based on the kind of a supercomputer, it is identified by the flops that it can handle. So 1 trillion flops is 1 T flop, and then this is the NVIDIA RTX 4090, which is now being used for AI and graphics. And then similarly, you have like 1 quadrillion flops, which is 1 P flop, which is the IBM supercomputer. And similarly, now the exaflops are like, this is where the US NASA and all these, they use these supercomputers, which has got these exaflops to compute various images and identify the signals, and a lot of digital signal processing, and then also image processing is done by these exaflops. I mean, supercomputers which has the support of this exaflops. So this is a typical thing that you need to keep a tab on when somebody says that, hey, I have a supercomputer. What exactly is that supercomputer? And then what is the capacity of the supercomputer? Yeah. And let me come to the key characteristics of supercomputing. So one of the main thing is massive processing power. As we discussed previously, one of the application that I gave you is about the substation monitoring, or even the same thing is applicable even in Genco. In generation of power also, there are a lot of small systems that will keep providing the data and IoT data from the various gateways that comes and sits in one of the HES head-end system. When the head-end system collects all this data, it is supposed to give a immediate indicators, or performance indicators is what we call indicators about whether everything is good or something is bad. So for that, when you are trying to take a lot of these small data points and then compute them together with a single algorithm, and your one GPU or a CPU is not sufficient. So now we are talking about millions of GPUs and CPUs, hundreds of them coming together and then computing it parallelly and then giving in one output. So this basically what we say is it is a massive processing power. So massive means I am not able to explain it in words here, but technically, like your ChatGPT is one of the very common application now. A lot of these IT students and IT users will be understanding about the ChatGPT and how it works. Well, ChatGPT works on a very interesting supercomputing model, but they include virtualization also in that. We will touch upon that one also in our presentation here. What is the key or element of virtualization in this? So one is massive processing power, and how that massive processing power is achieved it is done by parallel computing. As I said previously, when I have multiple data points coming from multiple directions, first I have to process that and then identify whether it is really an indicator, and then include all these indicators together and then come up with a immediate answers, whether saying that it is a red, yellow, or a green. That is what people understand. When the substation engineer is standing in front of his monitor and looking at it, all he will understand is a red, yellow, or a green. Whether situation is good, it's bad, or is it something that he needs to be concerned about. So in that context, right? So to give him that single red, yellow, green, a lot of backend, in the backend, a lot of processing has to happen. And then that processing comes by parallel computing of multiple data points with multiple outputs, again mixing them together using a massive processing power. Now, the other interesting part about supercomputing is also about the connectivity between these GPUs and CPUs. How are these GPUs and CPUs in a supercomputer connected? They can be distributed. Since they will be distributed across, where on the same board it can be distributed, so you need to connect these. Interconnection is required. So there are a lot of these buses that we talk about, say compact buses and the CPCI and InfiniBands and all those things. So right now a lot of people use InfiniBand and Omnipath. At one point of time it was this ISA and CPCI compact PCI buses, but now we are using a lot of InfiniBand based cards. So one of the company called Netarian, which develops all these high-speed interconnects between the GPUs and CPUs. And now NVIDIA is also mastered in this art. So the third part is about the connectivity. One is the processing of the individual GPUs. And then second one is the parallel processing. That means you have one controller thread which will make sure that the all other GPUs and CPUs are given equal amount of workloads. So that is the parallel computing that it happens. Now, when the parallel computing is happening, how are these all connected? So that is through the high-speed interconnects. That is the third part of your supercomputer. And then comes the fourth part, which is the massive storage. So you need to keep writing into the storage and then again read. So you compute something, you put it at a place, and then the other application will pick it up. And then also, or the same application may pick up after computing something else. So based on your computing needs and then the algorithm, a massive storage is required before a final version of the output is being delivered. Before that is delivered, so you need to do a lot of computation and then you need to store that data. So maybe when you're processing, especially when you're processing an image, suppose if I take some space research center where I get huge piles of photographs, and then I have to process this and then pick up what I want to give a useful information. So first I have to analyze the picture, a lot of things like EXIF informations, analysis. That analysis goes into their reading the history of that particular thing, and then if there are any other pictures compared with that, and then how do you compare with that, and then give a final analysis. So for all these things to have funds, you compute and also you store that information in the temporary storage somewhere, and then you pull out and then finally give the output. So in that context, massive storage systems are one of the main requirement for your supercomputing. So when such level of hardware is being at use, so it generates a lot of radiation, it consumes a lot of energy and generates a lot of radiation. So this is a very standard thing. Like when you want to, a very simple analogy is when you are cooking, if you put a high flame, the cooking will be fast, but the heat that it generates will be high. When you cook in low flame, it cooks very slow, but it does not generate so much of radiation. So when so much of radiation or the heat is generated, you take the help of a fan or something. Similarly, I will take the same analogy here. When you are using more energy and which are energy intensive computations that are happening, during that time, you definitely need more power. So how do you manage this power? Megawatts of power. It is not the kilowatts that we do at home. It is a megawatts of power that is required. So when megawatts of power is required for a data center to compute where these machines reside and to compute what kind of electricity planning has to be done, that is one. So the SMPS part, like in your computer, you have the small SMPS, right? So similarly, we have this energy management solution for the supercomputer, and also advanced cooling systems. It is not like how we say that, okay, if you have to put a computer, not anymore now, but previously some 20 years back, like if there was a computer, there was a mandatory need of having a air conditioned room. It is no longer valid now, but that used to be the case previously because of the intense heat that it generates. Now the computers have become so advanced that they don't generate so much of heat. But when it comes to supercomputing, definitely when there is parallel computing and high-speed interconnects that are happening on a massive processing thing, so definitely there will be a lot of radiation, and then to reduce that radiation and to keep the system intact, so a lot of cooling application systems have to be introduced. So these are the 5 characteristics of any supercomputing device, and these have to be identified. Like, not sure how many of you will be working on the supercomputing part, but definitely these are the 5 major items that you need to look at. So I'm not going deep into these things to explain, but I just want to scratch the surface because we have a restriction with the time. So let me come back to the this thing of where these applications, I mean, where we will use supercomputing applications. So one of the main thing is weather forecasting and climate modeling. The reason why weather forecasting is because your weather changes very frequently and dynamically. Thanks to this supercomputing, now we know we can predict hurricanes, these thunderstorms, everything much earlier to their this thing, so that we can build an early warning system. So at least now, I mean, I no longer hear, at least our application now in WhatsApp, we get a message saying that there may be a thunderstorm. Please take care of yourself. At least an early warning system has been built. And how do they calculate all these things? Because there will be change in the pressures, there will be change in the temperatures, there will be the movement of the clouds, there will be various other environmental factors that these guys collect. Their climate and weather forecasting companies, they collect this data, and then they give that data in real time to the system so that it calculates and it predicts. Because here in weather forecasting, there is prediction. So the prediction states that, okay, from this minute, what is the status of the next 10 minutes? What is the status after 15 minutes, after 30 minutes? So you do an interpolation or an extrapolation of that, and then you figure out, okay, there is a possibility with this current and with this kind of a wind flow, the direction which is going, we may hit some kind of a rain at these coordinates on the earth, this latitude and longitude at this time, because of the wind speed is this much, so it may precipitate there, and then you may have a rain. So to do these kind of weather forecasting and building climatic models, right? So you need a super duper supercomputing application. So now we are only talking about the applications. I'm not going into the hardware of it. Now these are all the applications. So then this is scientific research. This has been our favorite topic right from our childhood. We have been hearing that NASA has got a supercomputer, and all these ISROs and everything has a supercomputer. They do all this astrophysics and quantum physics thing and all those things. But that is something that a very common thing, and it all initiated from there, the supercomputing part. And next is the engineering and manufacturing. One is very interestingly, in engineering, though we have given some small, some decent level applications like nuclear fusion research and crash simulations, there are a lot of other various applications which we use in manufacturing, especially this car manufacturings and all those things. They use a supercomputing to redesign their stuff. So they build various simulation models, not See, one advantage of having a simulation model is like you catch 90% of testings. You don't have to do a real-time testing. You can do a simulation testing, and then you can find 90% of the problems using a simulation testing. So the manufacturing industry gains it saves a lot of money and it's a lot of dollars just by building these simulation systems for quality check and verification. So more than engineering, the manufacturing sector definitely sees a huge advantage of having a supercomputer. Maybe not, we will not see in a small manufacturing setups, but when we are talking about a scale and the quality assurance and checks, if all these items can be found before the manufacturing, start of the manufacturing, so supercomputer helps all those identify the corner cases. So that is one big advantage. And we all know the ChatGPT. So that is all built on AI/ML model. So there, the only thing that it can survive is supercomputing. So previously we used to call supercomputing, and nowadays most of that has come down to a very interesting stage, because now we have a lot of these virtualizations and cloud systems that are coming up. So you rent a GPUs. So how these GPUs are set up, and then what kind of an artificial intelligence models can be run. So especially nowadays, we need to understand this particular part very well. So what is a GPU and what kind of a GPU is required for what kind of an application. Suppose if you want to run an LLM, and if an LLM is needed for your application, what exactly the LLM does? Is it really an LLM need, or is it an SLM need? Or is it just an agentic AI? So you have to understand these things and accordingly identify what kind of a GPU or a CPU is needed. So previously when this LLM started, when Meta gave their Olama, it used to run only on GPUs. It was very tough to run this Olama on any cloud machine with a CPU. So then slowly they have optimized the entire LLM, Llama LLM, that it can run on a 16 GB VPS machine also. So how this thing is transforming, this is a space where all the, at least the future data science guys and everybody has to understand this particular part. And similarly, we have this cybersecurity. So attacks, crypto analysis, and all these things are very, very important in the cybersecurity area. So we don't need a super duper computer, but definitely there is a lot of parallel computing that happens, which is also a part of the supercomputing only. So the parallel computing happens here, and then we identify the various threats, and then I accordingly kick in those anti-threat consumers. So this is one important part of the application. And similarly, the big data. Big data and space explorations, which we have been talking about, right? Like a very simple example is like, I collect this picture of the same space as the Earth keeps rotating around the sun, revolving around the sun, or rotating in its own axis. So I continuously take pictures during this 24 hours and then collect this thing, and then finally I collate all of that and then create a new image to see what is it, and then to read a lot of information about that. So these kind of space explorations, when you get huge data sets, how do you compute that? So this is a big data. This is a real big data that we are talking about. It is not big data is not about computing like millions of records. These are the real big data where we have multiple environment factors coming into the picture. So, to be honest, right, I'll just put it in a very simple. Previously, this data science or whatever we call AI/ML models, GPT transformers and all that. Previously, our computation was very, very quadratic expression based. y is equal to fx, you define the function of x, and then you give the parameter x, and then the function is defined. Based on that function, you are getting the value of y, which is a very simple quadratic expression, and then the function is defined with few steps of like 1 plus x plus x is equal to x, or y is equal, a function of x is like additive function is the f of x. So when I give the value of 1, I get f of 1 is equal to 2. Now, what has transformed everything? Nothing has transformed. The computation still remains the same, but the complexity has increased. In what way? So previously we used to add simple numbers. Now we are taking matrices. So I don't want to go into the matrix multiplication and addition and division, all these things, but explaining all those things, but definitely we all know that adding a numeric numbers from a numeric system is much additive. If you take an algebraic model, additive, commutative properties, these are all very simple linear functions. Now, when you bring a matrix into the picture, right, and then if you're combining matrices, adding multiplication, division, these are all very, very different scale of computing that comes into picture. So when you're doing that, you need to do a lot of parallel processing. To achieve the same speed of a normal quadratic function or a linear function, to achieve this in a matrix, you need to do a lot of parallel computing. So that is exactly what we are doing right now. So now the context has improved. The more and more things are coming into the context. Previously, we were not giving so many things into the context. We were saying like, let me put it in a very simple thing. 1 plus 1 is equal to 2. This is a numerical, in the numerical context. I add object 1 of type. I add a type of one object, an object of one type with the object of similar type. I get an object of similar type. So this is a very abstract thing. Now, when I want to do, how do I add the context? This is the formula. When I add the context to that, if I add the context as integers, then I get an integer. If I add the context of human beings, I get the context of human beings. So basically, you are adding the context to that. Now, the context will increase the complexity in that. So when the complexity increases, you need more and more logic to be applied to that. So then more of computing has to happen to give the right output. So let me go to the next slide. So this is a very simple supercomputer architecture. This is just nothing but the previous thing that we have explained it here. So I just try to put it in this thing. So at the bottom of the crux is your power supply. And then on top of it is where your CPU hardware. These hardwares is where your storage. Storage systems are set up, and on top of it is the network computing connectivity, and on top of the network connectivity is where you put all your nodes. But at the top lies your job scheduler. The job scheduler actually identifies, like when I said that there is a control thread and a worker thread or a data thread, right? So basically your job scheduler is part of your compute node only, but it is your resource manager or job scheduler which actually controls these other threads. So the compute nodes are the ones which actually compute and then give that, and then their interconnectivity is managed, mostly by InfiniBand in nowadays context. But there are custom bands that are available which get connected and then which gives that kind of a speed. So there are some convergent network adapters that come into picture. There are a lot of companies that do these convergent network adapters. So they mix and match a couple of bands together and then to achieve certain speeds. And also it depends on the kind of application that you are building. How much real time is your application? Not all applications that talk about real time are real time. So based on those things, they build this network connectivity between the nodes and also the storage part. Go to the next one. Oh, sorry. So I'll just go with the ChatGPT. So this is a very simple example that I can take, and then which actually where you also get connected very quickly because a lot of you might be using ChatGPT nowadays. So this is the data scientists or users submitting the jobs. This is where you give it the prompt. Now the prompt has to, one is you give the prompt, the AI agent picks it up, and then it checks whether it is available within its context. If it is not available, then it gives to the Llama. Llama actually does the required things. LLM does the required things, and then it generates based on the inputs that you give, it generates the required output, whether converting or a generation of an image, or even it can take your own database and then gives an SQL sequencer so that it can run that query and then give the required output. So basically the job scheduler identifies the kind of task and it allocates that kind of a resource. So I may need a GPU for it, or I may need if it is simple text processing or CPU text or a string processing, I would take a CPU of a low capability. And if it is an image processing, I may go for a GPU, or if it is something else, I would go for a high-end GPU. So one is that, and then on top of it, now comes my AI/ML framework. This to distribute across the GPU. So basically the scheduler will only create it and then gives to this framework so that it gets distributed to the actual GPUs for running that. And then this GPUs run in parallelism. So there is a data parallelism and then there is a nodes parallelism that happen. So when the data is given to these systems and then we run that in parallelly, and then the same thing again, I go back to that interconnect, how these between the GPUs, how this data is being sent across after partial processing, and then we build a complete output. And then how do you save this data onto the storage, and also the checkpoints. The checkpoints is basically to see whether a particular task, whether a particular GPU has completed its task and given the required output of it. Whether that, so that the next thread can start taking this as an input in the parallel world. So these are the checkpoints that you do. And then once this checkpoints is one part of it, and also you need to define the data pipeline. So where it starts and where it ends. So how the data traverses from one GPU to the another GPU if required, and how the data is shared across, and what is the pre-processing that it is done on that particular data, and then what is the post-processing. All these things put together, and what are the different streams of data that where a particular thing is getting executed, so that it all gets combined and finally gives you the output. So this data pipeline definition is also part of the ChatGPT. So basically when you say, hey, read this image and then give me the read this image and then give me the text in that on that image, that can be a simple query that you have put. So now first what I have to do is that image will be taken. First I have to see what kind of an image, what are the permissions to that image, whether it is a read only or it can be read or not. All those things I have to check. One is the image processing part, and then once the image processing part is done, then I do the reading of the text from that. So that is a different agent, or that goes to a different GPU. And once I get the data, now I have to format the data, whether I have got, what is the weightage of that particular thing, what is the what do you call the weightage, means basically whether it is 60% right or 70% right, whether it is matching to the requirement. It has to build that context, right? Because you are reading from an image a particular sentence, so it has to make a meaning out of that. So it has to check verification of that data, and once that is done, then ChatGPT actually understands from its own internal database and then finally gives you an output of what you are asking for, whether it is printing the text, or you may be asking, read this image and then identify the text. From that text, I want this. So based on the keywords that you get from the text, you may identify that it can be related to some essay, and then that essay has got these keywords, and these keywords give this kind of a meaning. So it can do 100 things. These are all the parallel things that happen based on the prompt that you have given. So all these things will be given to one GPU, and then the entire data pipeline will be set. And once the pipeline is set, it just processes meticulously and then gives you the output. And then the last one is anyway the hardware part of cooling and all that. So here I would like to take a minute or so to take us into the virtualization part. Why virtualization in I mean, when we are talking about supercomputing, what is the need for virtualization here? That can be a different topic altogether. But what is the most important thing that we are seeing nowadays is it is not just virtualization, supercomputing. They are doing a combination of virtualization and supercomputing, because that is the one that is giving us these cloud solutions. So high performance computing, HPC, is the new word that is coined on these terms. And so basically, to understand the basics of virtualization, you would have all known what is a virtualization. Basically, there will be a bare metal hardware. On top of it, you put a KMO or a VMware, VSX and all those things. And then you convert one single physical bare metal system into multiple virtual systems. And on those virtual systems, you put your own required operating system, like you can put a Ubuntu or a CentOS or a Kali Linux or a Windows and all these things, just like the VM player, what it is doing. So this is basically the virtualization. Virtualization is just a layer. Below that, it uses the same interfaces to the hardware, and they build these host bus adapters. So you have multiple host bus adapters for each and every host that is built on top of the virtualization. Suppose host is one machine, I can say. So if I have 10 machines on a single hardware, so there will be 10 host bus adapters, HBS, and then these HBS will interact with the actual hardware. And if it is a network, right, you will have only one network port that is going out. But each machine will have its own IP address. So there is a different network altogether. And this can be actual public IPs also. So during that context, your network adapter has to be opening a tap interface. So how do you configure a tap interface in your virtualization? So these are all part of the virtualization. Now, so basically, what is a VPS? VPS is nothing but just like any Linux machine. Suppose you bought a PC and then you have installed a Linux, and then you kept it in your room, and then you gave an IP address, and you are connecting through the cable and saying that, hey, 192.168.1.10 is the IP address of this Linux machine. So if I put the same thing on a virtual machine, so then that becomes a VPS machine. So basically, there is no difference between a physical machine that is sitting here to a virtual machine sitting. It is just you are accessing it through a IP address, and that is called a virtual private server. Now, just a small comparison between the supercomputing versus virtualization. Because until unless you have just a basic idea of these two, you cannot combine these two and to understand what is the HPC part of it. So basically, in supercomputing, you are using the raw power. It is a physical power. You are using the bare metal, and you are computing. You are taking the complete computation, all those CPUs and GPUs for computing your application. But in virtualization, on a supercomputer, when you put a virtualization, part of your computing goes to managing the virtualized servers. So basically, it is more of a resource utilization. And similarly, you have HPC clusters in supercomputing, which is high performance computing clusters. But in virtualizations, you have multiple servers, which are like cloud-based servers. And VMs, we call them as a VM. So you can scale with hundreds of nodes in a supercomputer. Like you can add few more nodes to this thing. But when it comes to virtualization, you keep on adding virtual machines. The more number of virtual machines, here you are adding a physical nodes, there you are using virtual machines. So this is almost like a performance is definitely a bare metal gives a better performance and a minimal abstraction compared to virtualization. So usually these VPS machines take away 40% of your computation only for the management part. But why do we still go with the virtualization is because the cost effectiveness. Though the performance may be deteriorated compared to a bare metal, but we still go with the virtualization for only for the cost factor. So workload, I mean, the AIML simulations and all that are much better on a supercomputing compared to your virtualized applications. So this is a very interesting topic to discuss, where we bring all these supercomputing and virtualization at an intersection point. So why do we need to do this? So on a supercomputing, you are giving a high performance computing, which is needed. In virtualization, you are giving multiple machines, you are replicating multiple virtual machines. Why do we need to bring all these things together? So the idea is to bring them together and then build a concept called HPC as a service. So this is like a lot of these casts that are coming. So this is also as a service, they want to bring it because supercomputing, not everybody can afford supercomputing. Now, when I want, suppose as a small company, if I want a supercomputing for some of my applications, which I want to run, I cannot afford to buy a supercomputer and keep it in my office. So during that time, they want to rent it out. They want to give it out. But when they want to give it out, I may not be use it 100%. So basically somewhere they need to add a virtualization so that the machines can be shared, because these are all part of the managed services thought process that come into picture. Hey, why don't I use this for multiple people? So in that context, they have to add a little bit of virtualization. Maybe not a 40% of efficiency going down, but maybe a 20% of efficiency going down, and still I can get the benefits of a supercomputing. That will be good enough for me, like a startup or someone to manage the costs. So that is the whole idea why this supercomputing and virtualizations are coming together to provide and reach, basically to give more reachability. So like everybody should be able to afford this and then go forward. So that is the whole idea of this intersection of supercomputing versus virtualization. Okay. So this is another interesting slide that I want to put. So this is exactly what we discussed previously also. The AML workloads will identify and then they give the inputs to the frameworks, and then that goes to the parallel processing, and then from parallel processing to virtualization containers, and then from there to the software, system software, and then from there to the supercomputing hardware. So this is how the entire flow goes down from the top level to the bottom. So AIML works on these kind of concepts. Whether your CPU or a GPU is a supercomputer or not is a different story, but definitely your AIML works based on the kind of data that you are processing and then the kind of algorithm that you are building. This is the flow that comes into picture. And now, the interesting thing that, so from the previous slide to this slide, it is all about how you want to do it on the cloud. As I previously mentioned, right, how they want to integrate both cloud integration, provide a supercomputer on the cloud. So for that, the cloud integration is coming as a, on top of that, all these things, it is coming as a layer, which is providing a lot of people now the advantage of supercomputing. So there are some supercomputing provider companies. I think AWS is providing something like that. And then there is another company, DigitalOcean, is also thinking of putting something. NVIDIA is anyway there. AMD is also trying to come up with some kind of a rack space for the competitions. Now let's go into what is the future of supercomputing. So eventually the supercomputing will get into a much bigger this thing where heterogeneous accelerators have to be combined together to build a meaningful things. Like how we were able to integrate text, image, audio, video processing all put together into one single thing. It is not a single computing, but it is a multiple parallel computing putting together, and then we are able to generate applications. And then going forward, there will be much more bigger integrations and various applications to be coming together and combining them together. So that is where the supercomputing is going to be a much bigger, from the exascale to a zeta scale. Like we saw it, exaflops and T-flops, P-flops and exaflops. So this will definitely scale to a better hardware and better thing. So that is the zeta scale. That is what people are imagining. And then one of the biggest thing that they are looking is to solve various problems in medicine and climate. These are the two important things. Medicine will forecast what is going to happen to our body. And then climate is going to tell what is going to happen in the next few minutes or few hours or few days with the climate around us. So these are the main applications that people are focusing and then taking it forward. So I want to stop here and I want to try answering few questions. Please let me know if you have any questions. So if there are no questions, I'm okay if we can end this session. Ravikiran garu?
Yes, sir. Yes, sir. Please wait a minute, sir. Our faculty will convey vote of thanks, sir.
Okay, thank you.
Rosie ma'am, you can conclude.
Hello, sir.
Yes.
I request the faculty members to ask any questions. Okay, sir. I think I'll give the vote of thanks.
Thank you, ma'am.
So we sincere, first of all, thank you, sir, for sharing your journey with us and for that wonderful session. We sincerely thank you for your insightful session on supercomputing, covering flops, architecture, applications, ChatGPT's use of supercomputer, BPS, and the intersection of supercomputing with virtualization, and also AI/ML workloads on cloud-based supercomputing and virtualization. All these things added value to our knowledge, sir. And the participants really must have enjoyed the session. And thank you for this wonderful session, sir.
Thank you. Thank you. Have a nice day, ma'am. Thank you for your.
Thank you, sir.
Prakash,
Thank
sir,
you.
thank you for joining with us, sir.
Thank you, sir. Thank you, sir. Anytime. Bye. Thank you.
Participants, please. Started.
Samrat sir,
Sir. Sir,
what is the status, sir? No.
we'll start at 3:30 again, sir.
Okay, sir. You please convey the participants, sir.
Yes, sir. Participants have a notepad.
Water.
Start the session.
Water also. Water also.
Now
I feel very privileged.
Department of
Shall I continue, sir?
yeah, a bit.
I feel very privileged. Session, Dr. Nilesh Chandra Garu, an accomplished academician, researcher, and corporate trainer with deep expertise in high performance computing, parallel computing, and GPU based computing. Dr. Nilesh Chandra Garu received his PhD in 2019 from Visvesvaraya National Institute of Technology, Nagpur, where his research focused on parallelization of the finite element method on graphics processing units. Since then, he has established himself as a leading expert in CUDA programming, OpenMP, OpenACC, and deep learning based parallel architectures. He is also a NVIDIA certified CUDA programming instructor under the Deep Learning Institute program, conducting several corporate trainings, faculty development programs, and workshops across the country empowering professionals and academicians in advanced computing technologies. Currently, Dr. Nilesh Chandra Garu serves as an assistant professor at the Indian Institute of Information Technology, Nagpur, and also works as a senior research fellow at Multicore Ware Incorporation. He has previously held academic positions as assistant professor, senior grade at Vellore Institute of Technology, and industry roles such as senior parallel computing architect at Brain Grid Technologies. Over the years, he has also earned numerous certifications from NVIDIA, Intel, and deep learning. AI covering areas such as CUDA programming, multi-GPU computing, deep learning, anomaly detection, data parallelism, and accelerated data science. Thank you, sir, for giving me this opportunity.
Thank you, ma'am. Very good afternoon to all. So let me share my screen now. I hope my screen is visible. Okay, so we have around 1 hour and 15 minutes. So I'll try to keep my presentation very precise because we have only 1 hour of time. And the agenda for this presentation is like, first of all, I would like to discuss the limitations of multi-core CPU. And the theme of this session is we want to discuss what is graphics processing units and how how they are being utilized for different applications. But to understand the GPU, first of all, it is important to understand what are the limitations of CPU side and why we are shifting from multi-core CPU to GPU. Then we will discuss what are the type of applications where GPUs are dominantly used. Then the architectural differences between CPU and GPU, right? And finally, I'll discuss a very basic hardware architecture, GPU hardware architecture, which is quite old, but still it is relevant in today's context also. Okay, so that's the agenda for this session. And one disclaimer is majority of my work is on NVIDIA graphics processing unit. So the presentation will be slightly inclined towards the NVIDIA GPU. Of course, there are other GPU manufacturing companies are there, like we have Intel, AMD also, right? But as my majority of my work is on NVIDIA GPUs, so that's the reason I'm keeping this presentation related to NVIDIA GPUs. Okay, and if you try to understand the concept of this programming, GPU programming in the context of other GPUs also. So programming model remains similar with slight modifications you can expect, like syntax and all. But you can say the crux of the GPU programming remains same over the different vendors. Okay, so let's talk about limitations of multi-core CPU now. So these are some of the multi-core CPU examples mentioned here. These are quite old CPUs, but still you can see here these are the Intel Xeon processor series is there, and some of them are having 14 cores, 16 cores, 20 cores, 22 cores, etc. Right? The logic behind putting multiple cores on the same processor is to divide the task across multiple cores and execute them in parallel. And ultimate aim, when we talk about the parallel computing, would be to reduce the overall time required for that computation. Okay, so generally we have these many number of cores. And if you check your laptop or PC, which you use on day-to-day basis, which will be having around 8 number of cores to maybe 16 number of cores. Okay, so in general we'll be having only those many cores. And as I mentioned, if the number of cores are more, so the performance will be more, right? So to understand this, if I give a simplest example, let's say we want to perform a task. Let's say I want to shift 50 benches from classroom A to classroom B. Okay, so we have classroom A and there's a classroom B, and I want to shift 50 benches from classroom A to classroom B. Assume that this is the simplest task we want to perform, right? And now if I assign a single person to complete that task, and let's say the efficiency of this person is 1 bench per minute. Okay, so 1 bench per minute. So that's the efficiency of this person. So it will take overall time equal to 50 minutes because we have 50 benches to be shifted. So it will take 50 minutes. If I double this resources, so every resource again has 1 bench per minute. That is the efficiency, but we have 2 number of such resources. So overall time will be reduced to 25. And same way, if I make it 4, so it becomes 12.5. So you can see here, as the number of resources are getting increased, so overall time is getting reduced. So that is the idea behind the parallel computing. So in the context of computers, we have processor is the kind of computing resource, and inside the processor will be having multiple cores. Okay, and these number of cores are nothing but giving us liberty to execute different computations at the same time. Of course, provided that there is no dependency in between them, right? So as the number of resources goes on increasing here, you can see the performance is accordingly getting increased, right? So the time required for all these shifting benches is getting reduced as I'm going to increase the number of resources here, right? So that's the whole idea behind the parallel computing, and this is the reason we have these this is the reason we have these many cores present on our CPU side. Now, if that is the case, then why we are having only maybe 10, 24, 32 number of cores? Why I can't have, let's say, hundreds of cores on CPU side, right? Because logically speaking, if number of cores are getting increased, the amount of time required to perform the computation is going to be decreased, right? So that's the relation. So I would expect ideally that maybe I can have hundreds or thousands or even millions of number of cores present on the CPU side. But that is theoretical. If I try to do that, there are practical limitations are there. So let's try to understand what are those limitations. Why we'll not be able to put maybe hundreds or thousands of cores present on the CPU side. Okay, why do we have only a few tens of cores? So first of all, the limiting factor is cost, right? So if you check whatever the normal system you are using, its processor cost, and you compare the server grade processor, which may be having, let's say, more than 100 cores. So you'll see there is a huge difference between the cost, right? So normally I can get this sort of processors that currently we are using in our laptop or systems around maybe 20,000 to 30,000 or 40,000. Okay, so that is the normal, we can say, the cost for the processor, right? But if you try to compare the processor which I'm talking about, let's say server grade, so where the cost of the processor itself becomes very huge. For example, maybe in lakhs, right? So maybe I'll having a server grade processor which is having, let's say, 128 cores. The cost of the processor itself is sometime 2 lakh, 3 lakh, or 5 lakh rupees, right? And obviously it is not affordable in that for day-to-day life. So that is one of the limiting factor to put more number of cores on the CPU side. The next limiting factor is complexity, right? So we try to put many number of cores on the CPU side. So we have to handle the other dependent things, like I have different levels of cache memories, L1, L2, L3 cache memory, right? I have to synchronize them. In addition to that, on CPU side, we have a pipeline structure. So sometimes we have even superscalar pipeline structures. So these are the things which are going to introduce some sort of complexity, and it is not, it is going to create some overheads when we go on increasing the number of cores here. Okay. So this is the second limiting factor for having limited number of cores on the CPU side. The third limiting factor is size. Of course, you can see if the number of cores on the processor goes on increasing, it will take some space on your board, right? And if it goes on increasing, the space requirement goes on increasing, and the size of entire device goes on increasing. Also, it will increase the weight of the system, because when I start increasing the processor, it doesn't mean that only processor size is getting increased. So according to that, we are going to have uh, the other things, like we have to mount some sort of fan over there. Okay, so that's way again the size of entire the electronic device is going to increase, right? Size and weight also, in addition to size, weight also goes on increasing. And nowadays we want our systems to be as compact, as small as possible. But if you try to introduce more and more cores, the size and volume and your weight of the electronic device goes on increasing. So that is the one of the limiting factor again to put many number of cores on the CPU side. The most and important factor is heat and power consumption, right? So typically we know that when we start any laptop or the desktop system, uh, automatically a fan mounted on the processor start rotating. The reason is we have to ensure the temperature of the processor should not cross a defined threshold value, because the processor is made up of silicon material, and silicon material is having its own melting point, and if the temperature is going beyond that, then there is a possibility that the processor get damaged. Okay, and why there is an issue of heat? Because the processor is powered by electricity, and electricity is nothing but fluctuation of current. Okay, so generally what we have, the processor is having something is called as a clock frequency, right? And if the clock frequency is nothing but your current is getting on and off, and if the clock that current is getting fluctuated very frequently, it will start dissipating some amount of heat. And you might have observed that even when you're working on your laptop, and if you try to put it on your lap, so you'll feel that there is a increase in temperature in the laptop, right? The reason is the processor is getting power from the electricity, and inside that will be having fluctuation of current, and hence the temperature of the device goes on increasing. Okay, now solution for that is we can have a fan mounted on that, but uh, the problem is if we go on increasing the number of cores, the simple fan may not be suitable to control the temperature of that processor. So in that, we have to introduce some extra cooling mechanism, right? Maybe the liquid cooling mechanism. But the problem is if I try to introduce such sort of cooling mechanisms, then it will introduce again some extra power consumption, and ultimately it will result into the extra cost of handling that device, right? Because power consumption goes on increasing, so electricity goes on increasing in the same manner. Okay, so to maintaining such kind of devices is not cost effective. So that is again the reason for limiting number of cores on the CPU side. Then we have limited number of cores. So obviously the performance is limited for our applications. Okay, so these are the challenges when we try to put more and more number of cores on the CPU side. Now let's talk about what's the solution here. And the solution is graphics processing unit. Okay, so we'll try to understand now what is the how this graphics processing unit is going to help us in order to overcome the drawbacks of multi-core CPU, right? But before that, I would like to discuss about the brief history about this graphics processing units, right? So this GPU is not a new term. People started working on this sort of devices since 1980s, and around 1999, NVIDIA released its first GPU, right? So GeForce 256 was the name, and they marketed as the world's first GPU. And their intention of using that graphics processing unit is only limited to the computations related to gaming and animation. Okay, because if you observe the computations involved in the gaming and animation, uh, they are typically follow the same computing pattern or very specific computing pattern, but we have to perform those computations very frequently, right? And those who are from computer graphics background, they know how at a low level, whatever computer graphics related or games are performing the computation, it's simply nothing but some matrix computations. Okay, so we have to perform lot of matrix computations, and we have to perform very frequently. That is, we have something is called as frames per second. So frames is nothing but, let's assume a matrix, and we have to process that matrix. Let's say 60 frames per second, it means 60 times we have to process that matrix, or 120 frames means 120 times I have to perform the computations on that frame per second, right? And during that time, the whatever CPUs were there, they were not capable of handling this sort of workload, right? And that's the reason the NVIDIA and other companies like IBM, AMD, they try to design a new device that will only cater the requirement, computing requirement of games and animation, right? And that was their intention in early 2000. But around 2007, NVIDIA launched a programming model that is called as a Compute Unified Device Architecture, that is abbreviated as CUDA, and this enabled the general purpose computing. So since 2007 onwards, these GPUs are being utilized for not only the games or animation, but other applications where also the GPUs are required. Okay, so for that purpose also the GPUs were being utilized now. And today we call that graphics processing unit as GPGPU or general purpose GPU. Okay, so this is about the brief history of the GPUs. Now let's try to understand what is actually a graphics processing unit. So it is called as an accelerator, right? So it is going to accelerate the performance of any application, right? So obviously we are talking about the parallel computing. So it is also another kind of processor which is helping us to accelerate the performance of given applications. It is not a standalone device. That means we cannot have only GPU present in our system. We must have CPU, which is the main controller of entire system, and GPU is a add-on, or we can say plug and play device. Okay, so that's the reason we call GPU is not a standalone device. Then it is throughput oriented device, and it is a co-processor. So we will discuss these terms in a while. But before that, I would like to discuss some of the applications mentioned here where nowadays GPUs are dominantly used. Okay. First application here is related to again the games and animated movies. So nowadays we can see the video games or the animated movies are becoming more and more realistic, right? So if you compare the quality of this animation and video games, you will realize that the improvement is very uh, drastic improvement is happening. Nowadays, games are taking care of the physics related, concepts also. For example, the gravity. For example, the illumination source, right? The water flows, right? So how, with respect to wind speed, how that particular tree leaves are going to make movements. If let's say somebody is riding the horse, if the actor is having long hair, so how to simulate those hairs. So if you see, to in order to simulate all those things which we want to make sure looks like a natural things, so we have to introduce lots of physics related computations, right? And we have to perform those computation in a fraction of seconds. Okay. And now if we try to introduce those kind of high quality concepts here, then what happens is it will increase the computations very drastically. Okay. Now, if the computations goes on increasing, so obviously we need a processor that can handle the uh, that sort of computationally intensive jobs, right? And GPUs are nowadays dominantly used in order to accelerate the computations related to graphics. Because if let's say you're playing a video game and it is responding after 1 second when you press a key, then you will not be able to, or you will not enjoy that sort of game. As soon as I press the key, you want that particular action to be happened, right? So for that reason, we need huge computing power, and GPUs are suitable for handling that sort of computing power. Okay. We also have one of the application here is related to molecular modeling, or if I talk about the drug discovery. So in case of drug discovery, to treat a particular disease, we have to take different combinations of drugs, and we have to test whether it will work out on that particular disease or not. And if I want to do that, maybe billions or trillions of combinations are possible uh, with respect to some combination of drug. And we cannot make a human trial for these many combinations, right? Because any drug to be, successfully passed, the human trial is required, right? And that the space for the human trial is supposed to be again millions. And in that case, in order to discover any new drug, it is not feasible to, introduce that drug or inject that drug to the millions of patients and then check whether it will work or not. So that's not the, right way to test our drug. Now, what we can do is we can simulate the behavior of the drug treating to particular disease, right? So we can create an synthetic or artificial environment, and we can again introduce all these concepts related to computational chemistry, and we want to test whether these are the billions or trillions of combinations are there, they will work out or not. Now assume that to test one combination, if it is even taking 1 second, then you can see we have to, wait for trillions of seconds, right? In order to check all, because out of all these billions and trillions of combination, one of the, combination might work, right? We are not sure. We have to test, which is based on the some success criteria. So you can imagine, in order to test such kind of drug combination, how many possibilities we have to check here and how much time it will take, right? And it is if we try to do that sort of computations on normal PC sequentially, it will take maybe years of time in order to check whether that drug will work out or not, or which possible combination of drug will work out. Okay, and of course here also we need the computing power, right? So if we remember around 2019-20, we had the pandemic COVID, and during that time, uh, most of the supercomputers which had the GPUs were started utilizing. They halted all their applications, and people started utilizing the GPUs only to figure it out. So the drug which will be more suitable for that particular treating that particular disease. Okay, so that is what happens when we try to discover a drug, and which requires very huge computing power. And GPUs are also used in order to cater that computing power. The third application is mentioned here. Here we have applications related to fluid dynamics here, or computational fluid dynamics. So we have given this turbine, and the fluid is flowing through that turbine, and we have to test uh, what will be the temperature, what will be the pressure, if what will, with respect to the speed of that flow, we have to test. And typically, again, we cannot experiment with designing that turbine first and then passing the fluid through that and check whether it will fail or not. So it involves a lot of money in order to build that sort of turbine, and we cannot just simply make it and test with respect to different fluid speeds. So in that case, we have to again synthetically design this sort of domain in CAD applications. And in the CAD, we design that particular geometry for that particular turbine, and we simulate how the fluid is passing through that particular turbine by again ensuring the some physics and mathematical laws, and we can simulate at what particular time or what particular value of the pressure the turbine may fail. Okay, so that is to get the insights about what should be the speed of the flow, or how I'm supposed to control the speed of the flow into that turbine, right, without any damaging that particular turbine. Okay, so again, here also we have to discretize this domain into millions and billions of nodes, and we have to solve the systems of linear equations, which could be of size billion cross billion. And to solve such sort of equation, it requires a lot of time and computational power, and GPUs are dominantly used over there also. Okay, and the final and very important applications is AI, right? So we know that what's the importance of graphics processing unit in the field of artificial intelligence, right? So we can even say that without existence of these GPUs, right, we would have not seen the progress of this AI in this decade, right? So just to give you a simple case study here. So the Chat GPT, the first version of Chat GPT, right, was trained over 10,000 NVIDIA GPUs, and the training time was 2 years, right, in order to make that GPT model. So it took almost 2 years, and 10,000 GPUs 10,000 GPUs were utilized for 24/7 in order to train that model, right? If you don't have these many GPUs, now it may take maybe hundreds of thousands of years to train such kind of models on normal CPUs, and that is not feasible, right? And now you can see the race is people, various big short companies are trying to purchase more and more this NVIDIA or other GPUs, because they are kind of the heart of training AI models, because most of the no matter how you optimize your models, finally you have to train them on the GPUs in order to train faster, right? So this is one of the most important application nowadays where GPUs are used frequently. Okay. So this is about the type of applications we have. Now let's talk about actually what is GPU. And as I mentioned, we call it as an accelerator or coprocessor. So let's try to understand it. So in any computer system, so we will be having a main processor that is called as CPU, right? On motherboard, we'll be having CPU embedded on that board. And the GPU or the graphics processing unit is optional processor. It is also a processor, but it is optional, right? It is not mandatory. So the main control is always toward the CPU. And if you have GPU, you'll be utilizing it only for the special purpose. For example, only the computationally intensive task. We are not going to use it for the normal computations. For example, right now I'm using Zoom application. I'm also using some PDF viewer. For handling those sort of applications, CPU is enough, right? So GPUs are used only in case where your applications are computationally intensive, right? So those tasks will be performed on the GPU, and GPU execute them in parallel. So on GPU, which is having the computing power compared to the CPU very huge, it will perform that computations in parallel on GPU, and the results will be given back to CPU again. And again, the control is towards the CPU. So if you observe this flow, only in case of computational intensive job, we are using GPU. So that's why we are mentioning it as a coprocessor. So main existing processor is CPU. This will act as coprocessor. And it is an accelerator, meaning is that it is having huge computing power compared to CPU, and its job is to run that computations efficiently in parallel so that overall time required will be less compared to CPU. Okay, so that's the reason I'm calling it as a accelerator. Now it is a heterogeneous computing architecture, right? Because I'm saying on the same motherboard, I'll be having a processor CPU as well as I'll be having GPU, and both are having different architectures and we are going to use it as a one, right? So two different architectures coming together, and we will be utilizing its computing power. So that's the reason we call it as a heterogeneous computing architecture. Okay. Now, GPUs are not an intelligent devices. That doesn't mean that GPUs are useless. It's simply that it takes orders from the CPU. What are computations you want to perform? The way you want to perform, you will mention in terms of code, and the code will be invoked from the CPU side, and GPU will exactly follow the way code is written. It is not going to, use some sort of intelligence, right, to optimize that code. So unlike the CPU sometimes try to optimize the code or execution by itself. So GPUs are not going to do that. So it simply takes order from the CPU and execute as it is. Okay, that's why we refer it as a not an intelligent device. And most important thing about the GPU, it contains thousands of cores, right? So I mentioned that on CPU we have few tens of cores, but on GPU we can have thousands of cores, and over which we can launch millions of threads, and that can be executed in parallel, right? So the major difference between CPU and GPU is with respect to number of cores. On CPU, I mentioned that only few tens of cores are possible, but on GPU, we can have thousands of cores. Okay. If I recall correctly, the latest GPU GPU architecture released by NVIDIA, which is having more than 15,000 cores. Okay. Now you can imagine on CPU side, I can have 20 core, 30 cores, or 32 cores, or even max to max, I may be having, let's say 100 to 200 cores, right? But on GPU, I'm having 15,000 cores present. And of course, you might be wondering the limitation that we discussed on CPU side to increase the number of cores, whether it is also applicable on the GPUs or not, because both are the processing devices. So the limitation of CPU is again possible on the GPU side also. Okay, but there is a trick here how GPUs are designed in order to increase the number of cores. Okay, we'll discuss them in shortly. And finally, GPU is not a standalone device, right? So what do you mean by that? I cannot replace CPU by GPU, right? Because though I'm saying GPUs are having thousands of cores, so why we are still using CPU in that case? Okay, let me give you the simple analogy with the same example. Let's say again we have a classroom A and classroom B and the same computer work. I want to shift 20 benches from classroom A to classroom B, right? So in this case, does it make sense if I assign, let's say, 5,000 people to do that job? Does it make sense? No, because the task is simpler. Even maybe a single person can perform that job within 50 minutes, right? That is okay. I can have 50 minutes, and that is obvious. I don't want to shift them in, let's say, 1 second or like that, right? So if the application is not that intensive, why to use that sort of device? Okay, and even if you try to assign that sort of job to the 5,000 people, so it will create chaos, right? Because first of all, handling them 5,000 people itself is a overhead, right? And we have a small job to shift only 50 benches. We have to synchronize them, out of which only 50 will be shifting the benches, right? And remaining people will be simply waiting over there. Because the max to max, I can divide the job across 50 students, because 50 people here, because 50 benches are there. Okay, so the thing is, I want to convince is that not always we want GPU. Only if you have a task which is computationally intensive, then only we can use this GPU. If your task is not computationally heavy, and if even then you try to use the GPU, you will realize that for computation will take even more time compared to CPU, right? So winning game is, first of all, you have to bring the computationally intensive task, then only it makes sense to parallelize on GPU, right? For example, the applications like Zoom, the browser, your PPTs, right? So if you try to open these applications which do not demand a huge computing power, in these kind of applications where CPUs are very well optimized to handle the workload, right? But if I take another example where I want to train, let's say, a neural network, right? In that case, it requires uh, too many computations to be performed, right, in forward and backward propagation. And in that case, the CPU might not be suitable because we have millions and billions of computations to be performed in every iteration, right? So there is a strict line between these when to use CPU and GPU, right? So unless you have very huge computations, it is not recommended to use the GPUs. Okay, and that's the reason we cannot replace CPU by GPU, even though if it is powerful, because in the general purpose computations, CPUs are more suitable. Okay, fine. Now to compare the computing resource between single core CPU and single core of the GPU, right? So you can see here a single core CPU is very powerful, right? Compared to GPU, where the score of the GPU is less powerful. So what do you mean by powerful? So generally the you can say processing capability of any core is determined by the clock frequency to which it is tuned for. So If the clock frequency is higher, that means your processor or the core can crunch more instructions per second. And if it is low, means it will crunch less instructions. So it determines the speed of your processor, right? So in that context, CPU cores are tuned with higher clock frequency compared to GPU cores. Then as the clock frequency is higher, so obviously they will consume more power compared to GPU cores. And on CPU side, we have a complex control hardware. So on CPU side, we have the pipeline architectures where it is going to determine the branch predictions, right? So it is going to avoid the pipeline bubbles, right? So for that reason, we have a complex hardware on the CPU side, whereas on GPU side, that sort of complex hardware is not present. Okay. And CPU cores are good for performance, right? So good for performance means they take care of how fast that computations need to be performed. Okay, so that is the philosophy of the CPUs. Whereas on GPU side, they don't care about how fast that computation to be performed much, but they rather care about how much work I can perform per unit time, right? Because I'll be having huge number of cores. So I'll talk about how much work I can perform per unit time. So that's the focus on the GPU side. Okay. So to understand that performance and the throughput, let's try to take a simple example here. I'm having, let's assume, a task to dig a 400-meter big hole. That is my task. And let's assume the E stands for efficiency and T stands for time. Okay, a simple task to dig 400-meter big hole. Now, let's suppose I will assign an adult to perform that job with the, let's say, efficiency is 2 meter per hour. Okay, that is the the efficiency of that worker, right? Now considering this, how much time it will take? It will take 200 hours to finish that job. Now if I try to increase the efficiency of that adult, right, I'll replace with highly efficient adult, then in that case what happens? The efficiency is increased from 2 meter per hour to 4 meter per hour. And now you can see the total time taken to complete that job is to 100 hours. Okay, earlier it was taking 200 hours because the efficiency is increased. Now it is taking only 100 hours. Now same way, even I'll try to replace with a highly efficient person. Then again, if the efficiency is 6 meter per hour, total time will be 66 hours. And even if I increase the efficiency further to 8 meter per hour, so total time taken will be 50 hours, right? So this is how the CPU's side, course works, right? So we try to make them more and more efficient, right? So maybe today they are able to, let's say, crunch 2 billion instruction per second. Maybe tomorrow we are expecting 4 billion instruction per second. So we are trying to make the CPU cores more and more faster, right? And ultimately, if I'm trying to make the hardware faster, so obviously your application is going to run faster on that hardware. So that's the philosophy behind the CPU cores, right? On GPU side, the game is totally different. Okay, so on GPU side, we don't try to make the resources very powerful or very efficient, right? For example, if I take the same task of digging 400-meter big hole, now instead of assigning that job to efficient workers, so I'll make them lightweight workers, right? So maybe I'll assign that job to some teenagers, right? Where efficiencies of one teenager is, let's say, 0.25 meter per hour, right? So this is very lightweight or less efficient compared to the previous examples we have seen. So here the highest efficiency was 8 meter per hour. Compared to that, we have here almost 40 times lightweight resource we have, right? But rather than having only a single resource, what I'm doing here, I'm having a bunch of resources here, and here it is count is 64. Okay, now in that case, if single worker efficiency is 0.25 meter per hour, but I'm having 64 such resources, so the overall efficiency becomes 16 meter per hour. right? 64 multiplied by 0.25 will give you 16 meter per hour. And total time required to complete that job will be only 25 hours. Okay, so point here is one way I can make resource very powerful. Other way I'll keep the resource lightweight, but I'll increase in numbers. And that's the difference between CPUs and GPUs, right? CPU cores are more and more powerful, more efficient, whereas GPU cores are less efficient, but they are huge in number. And that is the reason we are able to put these many cores on the GPU side. Okay, so that's the major difference between CPU and GPU. And if I summarize those differences, it is mentioned here. So I want you to just quickly have a look on this. Okay, so whatever we have discussed so far is summarized in this particular slide. Now, let's try to understand the more architecture specific differences. But before the difference, I would like to first, mention what are the similarities between CPU and GPU. Okay, so both are processors, right? CPU and GPU both are processors. So obviously, they must have their own memory, because whatever computation you are going to perform on CPU, first of all, it will be placed into the CPU's RAM, and then your processing units are going to perform read-write operation by computing on that. Okay, so this is with respect to CPU, and I'm saying that GPU is also a processor. So obviously, whatever computation I want to perform on GPU, so for that data required for that computation must reside on the GPU memory, right? And as I mentioned, CPU is embedded on the board, whereas GPU is optional. It is a plug and play device. So there will be slots present on the motherboard where I can plug in that particular GPU, right? And these memories are connected over the data bus. Okay, so we can transfer the data between CPU and GPU over this data bus. Now, why I'm going to how I'm going to do that? So let's suppose there is any computation we are performing, let's say on CPU side, right? And if the data is on GPU, from CPU side, I cannot directly access that data because they are physically separate devices, right? And same way, whatever computation I'm performing on the GPU, and if the data is present here, I cannot directly access the data on the GPU memory. That is not possible because those two devices are physically separate. Okay, so first of all, what I have to do, whatever data required between CPU and GPU, first of all, we have to transfer over this data bus, right? For example, let's say I want to perform any computation on GPU side, right? And if the, let's say, data is present on the CPU memory, I will first of all transfer it to the GPU memory, and then the GPU cores or the threads will get access to that data. They'll perform read-write operation and they'll perform the computation, whatever required. The same way, if now this data is present on the GPU side and CPU wants to perform some operation on that particular data, then first of all, it needs to be transferred from GPU to CPU, and then only the GPU process or threads will be able to perform read-write operation over here. Okay, so that data movement is required when we want to perform the computation on GPU, right? Recall, I mentioned GPUs are used only for computationally intensive tasks. So in only the computationally intensive tasks are getting executed on GPU and rest of the tasks are getting executed on CPU here. Okay, so that is the common between CPU and GPU. That is the memory. Other differences, if you observe here, on CPU side, major focus is not on the number of cores, but major focus is on the control unit and the cache memory. So the control unit will be sophisticated here, and the cache size will be larger on CPU side. Whereas on GPU side, maximum focus on number of cores. So these green region or the squares indicate number of cores, right? So they have just mentioned the size of the core more compared to the CPU side. So in just to convince that more focus is on having more number of cores on the GPU side, whereas on CPU side we want to make these processing units faster and faster. So for that we have cache memory and the sophisticated control unit. Okay, so that's the difference between CPU and GPU. Okay, now this is the simple GPU architecture we have here. This is called as a Fermi GPU architecture. Again, this is specific to NVIDIA I'm talking about. And this is a very old architecture, but of course, the latest GPU architectures may have some differences with respect to this Fermi. But if you see, this is the base architecture over which all the recent architectures are designed. And there are many things common in between this old Fermi architecture and the latest GPU architectures. Okay, so idea is like this. So we will be having number of cores here. The green squares indicate a single core. Okay, we call it a GPU core or CUDA core. So these cores are grouped together to form something called as a streaming multiprocessor, SM, right? You can see here there are 32 cores grouped together to form one streaming multiprocessor. And these streaming multiprocessors are grouped together to form something called as GPC, graphics processing cluster, right? And these are the graphics processing clusters. We have 4 graphics processing clusters here. They are grouped together to form entire GPU. Okay. So cores are grouped together to form streaming multiprocessor, and streaming multiprocessors grouped together to form GPC, and GPCs are grouped together to form GPU. Okay, now how to calculate number of cores on the GPU? So it is simply nothing but the multiplication. How many SMs I'm having here? So I'm having 4 SMs here in one GPC. How many GPCs I'm having? 4 GPCs. And how many cores per SM I'm having? 32. So logic is 32 cores per SM multiply by number of SMs per GPC, that is 4, multiply by 4 GPCs. So 4 into 4, 16, 16 multiplied by 32, it becomes I think 512. Okay, so in this GPU architecture, I'll be having 512 number of cores present, right? So likewise, maybe the latest architectures will be having maybe more variations in this. So maybe the latest architecture is having, let's say, 120 cores per SM. Maybe we will be having 40 SMs, right, or 80 SMs, and accordingly you will get the number of cores, right? So 10,000, 15,000, whatever. But the organization of cores will be again similar fashion, right? So as we on the top we have GPU. GPU is comprising of GPC, graphics processing cluster. Inside the graphics processing cluster, we'll be having multiple streaming multiprocessors, and inside the streaming multiprocessor will be having multiple cores. Okay, so this is how the cores on the GPU side are organized. Okay, now if I zoom in a little bit here in the GPU hardware, so if I talk about only one SM, you can see this is how cores are organized. So we will be having for this entire SM, there will be L1 cache. We'll be having some sort of programmable cache memory will be there. Some registers will be available here for these many SMs, cores. Okay, we have double precision units. We have load and store to perform the data loading and storing into the memory, right? So we'll be having some special function units in order to perform the computations related to trigonometry or logarithmic. Okay, so this is how one SM looks like. And if I zoom a little bit more, this is how a CUDA core look like, right? So we'll be having some floating point units will be there, some integer units will be there to perform the integer computations, right? And these are again load stored units are there to perform the data read write into the memory, and these are the SFUs. Okay, so this is very old architecture, but the latest architecture, if you try to understand the GPU architecture, so in addition to these normal CUDA cores, you can expect even the tensor cores, right? Because nowadays most likely the GPUs are utilized for AI workload. So to handle that AI workload, they have introduced the special cores. Those are called as tensor cores, right? So those are not mentioned here, but we'll be having some tensor cores also that handles the neural network training related to workload. Okay, fine. So this is how GPU architecture looks like. Now, before I conclude my presentation, I would like to play a short video, and that is going to give you much more insight about how CPUs works and how GPUs works. Okay, a short video is there, almost 4 minutes video is there. Let's play that video first. I'll explain side by side what they are trying to demonstrate here. Even the audio, if it is not audible, don't worry. We are going to much focus on what are the visuals they are going to represent here. So let me start that video now. So they basically wanted to demonstrate how CPU works and how GPU works, and to explain these terms to a layman, they created these two scenarios. So first, they have created a paint gun that is going to throw a paintball at specific rate, and the job of that paint gun is to paint a smiley over this board. Okay, there is a whiteboard, and first of all, let's try to understand how it is going to paint. Look, so you can see here the paint gun trying to throw one paintball at a time. Okay, so it throws one paintball. In the next, it is going to throw a paintball at different location, third paintball at different location. And meanwhile, the host is interrupting and trying to increase the speed of that device, or the I can say the rate at which the paintball is getting thrown. Okay, so that is kind of related to increasing the clock frequency on the CPU side. So now you can see the paint gun is throwing the paintballs at higher rate. You can see here. Right? So you can see the entire smiley is drawn by that paint gun, which is kind of similar to a sequential CPU, right? So sequential CPU is going to process one instruction at a time. Okay, here its relevant is it is throwing one paintball at a time. Okay, now let's try to understand another device which is also going to paint something, but it is kind of relevant to GPU. So let's first of all watch this entire short video, and then I'll explain. Okay, so you have seen now how GPUs works compared to the CPU, sequential CPU. Okay, so you can see now, instead of having one paint gun, we have almost 1000 paint guns are equipped together, and they will be treated as a single unit, right? And every paint gun, you can see this pipe is going to throw one paintball at desired location. It's not like that it is going to throw at any location. So for every paint gun, the location is already defined, and that paint gun is going to throw the paintball only at the desired location on this screen. Okay, but the good thing is that all paint guns can perform this task at the same time, because there is no dependency that first this paint gun is supposed to throw, then another paint gun will start, right? That sort of dependency is not there. So all paint guns can throw at the same time, and the entire, you can say, painting of Mona Lisa is um, painted by or painted in 1 unit of time, right? We don't need multiple iterations to perform that painting. Unlike in the previous case, we have seen the smiley is drawn by the paint gun, one paint gun ball at a time. Okay, so basically that's the difference between CPU and GPU. Okay, so to conclude here, we have understood the CPUs, what are the limitations of multi-core CPUs, what are the challenges that we face in order to introduce more and more number of cores on the CPU side. Now, how the GPUs are going to overcome those challenges by introducing thousands of cores. We have seen that. What the architectural differences between CPU and GPU we have seen. Then also we have seen what are the type of applications where GPUs are being utilized, right? And finally, we have seen a short demonstration to tell the difference between CPU and GPU. Okay, so I tried to make it crisp as possible. Now we are left with almost 10 minutes before we conclude the session. Now I would like to make the platform open for the discussion. If you have any questions related to this topic that we have discussed so far, feel free to ask. Okay. Thank you. If you have your question, any questions, you can ask by opening the mic, or you can paste it in the chat box also. I'll be happy to take it. Yes. Is there any question? Feel free to ask. I just want to ask host, hope the participant have access to unmute themselves, or at least have access to the chat window where they can put their queries. Yes?
They will send the chat.
Okay. So participants, you can post your questions in the chat.
Samrat sir,
Yes, sir.
who is taking care of vote of thanks, sir?
Rajalakshmi, sir.
Rajalakshmi, are you there?
Yes, sir, I'm there, sir.
Your voice is low, Rajalakshmi.
Sir, am I audible, sir?
Yeah, but it is low. You can convey vote of thanks, Rajalakshmi.
Yes, sir. Thank you for giving me this opportunity, sir. Dr. Nilesh Chandra, sir, has provided great insights about quantum computing and its applications and the relating things to quantum computing. This is a wonderful session, sir. Thank you for sharing your knowledge to us, and thank you for everything, sir. Thank you, sir.
Okay. Thank you. Thank you all. Bye.
Participant.
Sir, Samrat sir.
Yes, sir.
Samrat sir, am I audible, sir?
Yes, sir. You are
Lakshman sir is willing to join, sir.
is ready, sir.
He is ready, sir.
Yeah. So then we can go with the session, sir.
Yes, sir. Yes, sir. Who is taking care of introduction of
Prashant, sir.
Prashant? Prashant, are you ready? Prashant, Mr. Prashant.
Sir, I think so. Prashant is not yet available. I'll just call him, sir. Yes, sir. Prashant is here. I'll make him the co-host so that he'll be able to unmute, sir.
Yes, sir. Yes, sir. Prashant, please introduce Mr. Dr. Lakshman.
Prashant, you can unmute yourself now.
Okay. Good evening, respected resource person, faculty members, and participants. Myself, Prashant, working as a lecturer in Department of Computer Science, PBSC College of Arts and Science. We feel fortunate to have with us today our resource person, Dr. A. Lakshman Rao Garu, a dedicated academician and researcher who has been shaping the future of computer science for the past 18 years. Dr. A. Lakshman Rao is currently working as an assistant professor in the Department of Information Technology at Aditya University, Surampala. He has an excellent academic background, having completed his SSC from Sarada Vidyalayam Sattupalli, intermediate from Gautam Junior College, Vijayawada, BTech in CS and IT from BVC Engineering College, Odaleru, and MTech in Software Engineering from Godavari Institute of Engineering and Technology, Rajahmundry. He was awarded a PhD in Computer Science and Engineering from Andhra University, Visakhapatnam, in July 2024 for his thesis titled An Efficient Deep Learning Framework for Android Malware Detection. With a total of 18 years of teaching experience, he began his career as an assistant professor at Sunflower College of Engineering and Technology, later worked at Akula Gopaya College of Engineering and Technology, Tadipalligudem, and then as an associate professor at Pragati Engineering College, Surampalam. And he served as an assistant professor at Raghu Engineering College, Visakhapatnam, and has been associated with Aditya University since 2021. His research interests include machine learning, deep learning, malware analysis, and cybersecurity. He has made significant contributions to the academic community by publishing 91 Scopus Index research papers, securing 5 patents, and being actively involved as a life member of CSI and IST. In addition, he has been invited as a resource person for numerous workshops, webinars, guest lectures, and AICTE-sponsored faculty development programs across reputed institutions on machine learning, deep learning, data analytics, Python for data science, predictive analytics, and medical image and signal processing. Dr. Lakshman Rao Garu has constantly contributed to the academic excellence and knowledge dissemination, mentoring faculty, students, and research scholars in emerging areas of computer science. His achievements include completing 10 NPTEL certifications and 3 course area certifications, further strengthening his expertise. Currently, he is also serving as a resource person for the EduTech Nest Data Science Data Analytics course. Thank you. We are eager to gain knowledge from you, sir, and the session is yours.
Thank you. Thank you, Prashant. Ravikiran sir, can we start the session or can we start
You
at
can
5
start,
o'clock?
sir. You can start. No problem.
Okay, sir. Okay, I will share the screen, sir. Sir, are you able to see my screen?
Yes, sir, it's visible.
Okay. So thank you everyone, and we are now reaching the final stage of this ATAL FDP. I thank very much Ravikiran sir. He is always having very enthusiasm for conducting these type of workshops or FDPs. Not only this, he organized several FDPs. In that, I also acted as a resource person for several FDPs. So he's always very eager to conduct these types of workshop, especially in the new technologies like quantum computing, supercomputing. These are the really new technology where most of the people are not having much knowledge. So thank you very much, sir, for giving me this opportunity. But today we coming to the end of this session. So my topic is given as the ethical considerations in advanced computing. Of course, it is not possible to discuss more technically, but we will summarize the whole session, whatever all the sessions, whatever we discussed, like supercomputing and also quantum computing and all other the techniques. And now we will come to the conclusion and we will try to see what are the ethical considerations in the advanced computing. But before that, I will try to revise or recap whatever the latest or advanced technologies we discussed, like AI, machine learning, deep learning, supercomputing, quantum computing, cloud computing. All these I will discuss. Of course, we know all these, but before going to the ethical considerations, first I will try to introduce all these within a less time, and later we will see the ethical considerations. So I think this session may be boring to you because we are coming to the end, and generally ethics in our course also, generally if we come across the ethics, we may feel like, okay, we know everything. But anyway, there is the need to learn all these things, even though we know it is compulsory to learn all these things. That's why this topic is especially added at the end of the just a second. Okay. So this is the agenda. Part one, we have the quick recap of supercomputing, AI, quantum computing, and later we will see why ethics in technology, why these ethics are necessity, and we will see some key ethical issues in AI, in supercomputing, and in quantum computing. And we will also see what are the frameworks like global and Indian frameworks available for uh, standardizing these ethics. And we will also see what is the final discussion about these ethics. So that is the today's agenda of my session. So we will understand what are the key ethical issues in advanced computing, and we can also recognize what are different risks and challenges, and we can also know what are the frameworks available like IEEE and NITI Aayog. These are the frameworks available for ethical considerations, and we will see how these can be useful in the research. That is the today's agenda. So coming to advanced computing means in the we know advanced computing is not a single term. It is the combination of the multiple technologies, whatever we discussed throughout this FDP. So this is simply a next generation computing beyond the traditional systems. So as we know from the history of the computers started some long back, where they have only less processing units, and they have only they can able to perform only very simple tasks and with the big size. So those are started, those we call as traditional systems, and later so those are now developed. The size of the processors are also reduced and the computational power also increase. So these are nothing but the next in a single word, high performance computing. That means it give more performance with the less size. So that is nothing but the supercomputing. And artificial intelligence, you know, what is artificial intelligence? Through our brain. So the same type of so as we have the brain, in the brain we have the neurons. So through the neurons, we can have some intelligence. So our brain receive the signal. For example, when you touch any hard thing, so you remove your finger because your brain receives the signal because of the intelligence. So that we make it artificial. That is nothing but artificial intelligence. So we will discuss what is artificial intelligence and what is machine learning, deep learning. Of course, you know, but before going to discuss ethical considerations, first we will discuss at least the definition and examples, then only we will go. And quantum computing, yes, quantum computing is also a new buzzword. And of course, implementation part, it is still research is going on, but a lot of research work is going on. And so in simple words, quantum computing means machine can be in multiple states at a time. So while we are reading DFA and NFA, like in the theory of computation, you may know finite automata. So we have deterministic finite automata and non-finite finite.
Lakshman sir, your screen is not visible, sir.
Hello. Okay, sorry for the interruption. Due to the issue in the internet connectivity, it is disconnected. Okay. So, sir, shall I continue? Are you able to hear me, sir?
Yes, sir. Yes,
you are
sir.
audible, sir.
Okay. So this is advanced computing, like supercomputing, artificial intelligence, and quantum computing. Not only these three. So I have done this based on our FDP, of course. Even in cloud computing, also we call advanced computing only. So now coming to supercomputing. So what is the supercomputing? We already discussed in single and simple sentence. We call like high performance system, and which is used to design to handle the complex and data intensive task. So if we have a simple task, there is there is no need of supercomputer. But we have the very huge task. Definitely, we need supercomputers. And basically, the processing power of supercomputing is very high when compared to the normal computers. So these can be able to perform trillions of calculations per second. So that is also we measured in floating point operations per second. And coming to the architecture, so this is built with several thousands of processors that work in parallel so that it can make a massive computational speed. And coming to the application scope, it can be used in real time and large scale problems solving applications also. These can be used. So as you see from the diagram, simply we have one CPU, then we have parallel processors, then we call it as a supercomputer. Of course, for the supercomputer today, the definition may be changed. In the older days, the supercomputer is different, but nowadays supercomputer also come in a compact size. In the earlier days, we have the supercomputer in the large rooms, but nowadays the size also reduced, and as I already discussed that the size of the components are reduced and the capacity or the processing speed is increased. So example for the supercomputer, for example, we have Summit in USA, that is also one supercomputer, and in the Japan we have Fagaku, and in India we have called Param Siddhi AI, that is also we called as the supercomputer. These are the some examples for the supercomputers. And coming to the applications, so we use supercomputers in most of the applications, real world applications, like coming to weather and climate. We have some climate cyclone prediction. We know this. So we will receive some messages 2 to 3 days earlier when there is a cyclone. So any climate change is there. So all these can be done with the help of the supercomputer. And healthcare also we can use in the drug discovery. We can use. We have different modules in the supercomputer. We can combine and we can able to use in pandemic simulations. And defense and security also, like weapon testing and cryptography, strategic simulations. In the security and defense also, we can use the supercomputer, especially space research. Definitely, we need supercomputers like satellite launch modeling. And we know recently we use Chandrayaan. So how it works after going to that space also, how it can able to work means, so it needs a lot of processing power at that place also. It can able to work up to some days. Of course, they used some battery. But anyway, this type of processing power is also important. Yes, we have the code and we write the code as a software programmer. But if your hardware cannot handle, then it is not possible to do these type of miracles. So with the help of the supercomputers, the world changes its pace. An example, India also using the supercomputers in space technology. So these are only the few applications. Anywhere we have supercomputers, we use supercomputers in any of the technologies nowadays. But the problem is the cost is high, as we are using only our individual computers. Even with the high processor like 8 GB, 16 GB, with i7 processors, we have laptop up to 60 to 70,000. So, but if we need supercomputing capability, we need to invest 5 lakhs to 6 lakhs. That may not be possible. So, individual usage may not be possible. But as a government can also use, companies can also use. So maybe in future, we may think like that our systems also work like the supercomputer. That means nothing more than that processing can be improved, like RAM sizes can be improved and number of processor can be improved. So that can be possible. And next, so that is supercomputing. We know that. And next, artificial intelligence is also one of the advanced technology. So nowadays we are using the word AI everywhere. So everywhere we have the word AI, machine learning and deep learning. So what is AI? As I already told, it enables the machine to learn, reason and make decision like humans. So that's the name artificial. It is not actual intelligence. Actual intelligence we have as a human, we have the brain, that is the natural intelligence, but we can able to simulate the brain. So that's why we call like artificial intelligence. We can able to learn, we can able to reason, we can able to make the decisions like this. Our systems can also do this, like learning, reasoning and making decisions. So like if your system also behave with some intelligence, we call that artificial intelligence. So actually artificial intelligence is a broad term. Okay, so coming to the subject, we have some algorithms. Actually, those who taught AI, so we have some algorithms. But nowadays, in outside, you generally use the term AI in a broad term. That means any new technology comes, and when anything which can be used in the place of the human, we call like AI only, AI machine, like AI tools we have. So like ChatGPT, we are using the best example for this AI chatbot is the ChatGPT. So that is also we call like an AI machine or AI chatbot. So initially in the artificial intelligence, we have only the specific algorithms. If we use those algorithms, then only we call like AI machine. But nowadays, AI, we generally use the word and it becomes the general term. So anything uh, which can able to do like a man, if your system, any program, any algorithm works like your works like you exactly, humans, then we call like an AI. So what are different subfields in artificial intelligence? Is machine learning, deep learning, natural language processing. So machine learning means learning the patterns from the data, and deep learning, like example, neural networks for complex tasks. So actually the deep learning is more suited to AI in perspective of intelligence, because the neural network in deep learning exactly works similar to our human brain, as I told, which receives some signal whenever you touch very hot or very cold, you remove your finger, because the brain receives the signal. So that is input, and whenever it receives the signal, some processing is done in your brain. What is the processing? Remove your finger. So then output. So neural network or deep learning works in a similar way. It has some input, it has some processing unit, it has the output. But this processing unit can be done in multiple layers. So that is nothing but the deep learning. And natural language processing is nothing but the text handling. So if you have the text input can be processed, and anyway you can apply either ML or DL. So everyday examples coming to AI machines like ChatGPT, Alexa, Google Maps, Netflix recommendations. So most of the tools we are using today are AI tools. We know that. But anyway, we will try to see at least some applications. Of course, we know that. So AI is science of creating machines that can able to perform tasks like human intelligence. And coming to the scope, we have different subfields like ML, DL, natural language processing, robotics, expert systems. All these comes under artificial intelligence only. So what is the capability of artificial intelligence? Ability to analyze the massive data sets, recognize the patterns, adapt to the new inputs, and automate decision making. So one beauty with this AI is we can merge anything with this AI. For example, we have quantum computing, we have quantum machine learning also. So that is the beauty of this AI technology. That's why if we have some good knowledge in either ML, DL and artificial intelligence, we can learn the new technology and we match that with this, and that can be a new idea for our any research. Generally, if we consider research, if you write the papers in the existing technology, those may not be accepted early. But if we write a paper in the new technology, like you pick quantum machine learning is one of the new technology. Even the quantum computing is the new, but as I told, it has some practical problems. As I told, the lift is in two states. We are saying that in quantum computing, it is practically not possible, but we will try to see what happens if it is there. So if we mix machine learning, because machine learning is already proven technology, if you compute the power like humans, it is not possible to do analysis. For example, if we have 1 lakh rows of the data, it is not possible to read by a human. Then we go for this machine learning or deep learning. So if you merge this technology like quantum computing and machine learning, that can be a very much helpful, like applications, healthcare we can use, AI assisted diagnosis and drug discovery. Finance we can use like fraud detection, algorithmic trading. In education, we know adaptive learning platforms are there, chatbots for student support. So that means using the AI, the education field also using lots of apps. And daily life also we use virtual assistants like Alexa, Siri, navigation apps, e-commerce recommendations. So all those we can use, all those comes under AI applications only. So what is the impact means? AI is rapidly transforming the industries, reshaping the jobs. Of course, we may bother about that. Sometimes some of the jobs in the software industry are gone because of this AI. But the fact is, of course, some new jobs are also created. So TCS, for example, removed some 12,000 jobs, but is created some other jobs in generative AI. So that means those who can able to use these AI tools have the more opportunities. So that's why there are several AI tools also there. So recently I conducted one FDP on these AI tools. Of course, not me. We as Aditya University, we organized one FDP. So in that FDP, I also participated. So of course, we are using Excel, but in Excel also, you can ask the question. For example, we don't have much knowledge in Excel. So you want to find, okay, some of the sales, you have sales data, you can ask. So we have a tool for that. Like Excel plus ChatGPT. So what we are doing in ChatGPT, you ask some question, it will give answer. If you open your Excel sheet and you ask, for example, you have a column like sales. You ask what is the total sales, in which area more sales, or give the graph for city-wise sales or city-wise profit. Like that, if you ask, like ChatGPT, how we ask, so it prompts. So if you ask the question, lively, it will create some charts for us. So like that, number of tools available, whatever the concept I told, that is called ROS AI. In Chrome, you just open and you type ROS AI. So it will there is no need to create any account with Google. We can log in and you open it and it will show some Excel like structure. You upload any Excel and also AI prompt is also there. You ask some question for that Excel, it will give the result or whatever it may be. So that means if we don't know the formulas also in writing the Excel, we can use this. So of course you can use ChatGPT also, but lively we have available ChatGPT and Excel. So I'm just telling one example AI tool. Like that, there are several AI tools are also available, which makes our life happier. For example, to conduct a quiz. So how we conduct a quiz or MCQs quiz for a student earlier. So simply we type each, you can use either Google form or you can use maybe Microsoft Office form. So you enter one question and you give all the 4 answers. So select the best answer. That is correct answer, not best answer. So like that, we need to manually enter all those things. But nowadays we have several tools. For example, you explained unit 1 to the students. So you just save that file and give it to a tool called as Wayground, Wayground, I think, Wayground. So in the Wayground, if you just upload your PDF for unit 1 and you ask to generate 10 MCQs, it will generate 10 MCQs and it will also give a link for us. We will share that links to the students. And one important thing is it will create the MCQs based on our material only. That is very important. So of course, ChatGPT also generate, but it is not possible to give the link. But this Wayground AI tool, what it will do is it generate a link, and from that link, student can able to join and answer the questions with a very beautiful graphics. Actually, that Windows also good. So like that, number of tools came into the picture. So not only the students, even the faculty are also, if we use those, our task will be completed in very less time. So you know, I will pay 2000 to ChatGPT for every month. So the reason is I am using ChatGPT for most of the tasks because it is more accurate. Even for my research, for writing papers in the sense for coding I will use. So if you want to implement some deep learning algorithm, so if I got an error or if I get stuck or if I have some any new idea, whether this data set, how can I pre-process quickly, how can I apply the hybrid algorithms, or how can I merge with the quantum computing. So if I have anything, I will ask, and of course the free chat GPT also help us. But if it is a paid, I feel very comfortable. Okay, so like that, if we use the AI tools, our job can be very easily completed within the time. I think most of you are also using the chat GPT every day. So I'm also using the same, not anything more, but there are other several AI tools also available. Okay, so with those we can able to finish our task. Okay, coming back. So what is the impact means? Because I discussed all these, the impact of AI is more. So even we are saying that, okay, students are losing the jobs, but we are using the AI tools. We are using the chat GPT. So earlier, if you want to create the report, we sit and prepare by spending 1 and 2 hours time. But now, so if you draft just points in 5 minutes and give it to ChatGPT and you ask to create the report, and it will give the correct report. So we will recheck it. So we are using the AI tools even, but whether the student can able to use the AI or not, that depends on his job. For example, if you are using the AI for coding in interview, it is difficult, but you use AI for the study, it is very much useful. So that is the, as a teachers, that is the way we need to tell to the students, yes, you use the chat GPT, but to learn, not directly copy and paste. Okay, so coming back to our original discussion. So, okay, we discussed about machine learning, deep learning, and natural language processing, because these are the part of the AI. So this is definitely one of the advanced computing topics. So that's why we need to discuss a little bit. So machine learning simply a subset of AI where systems can learn from the data and improve the performance without any explicit programming. And coming to the key learning types in the machine learning is supervised learning, unsupervised learning, and reinforcement learning. So what is supervised learning? We can able to train on the label data for prediction. So this is very simple, and we have input and output. That is supervised learning. And what is unsupervised learning? So we can able to divide, for example, customers groups. So you want to just only the division. Unsupervised learning is nothing but the division. So a supermarket want to divide the customers with only up to 5,000 buyers, 5,000 to 10,000 another group. Are you considering the best example for Amazon and Flipkart? So whenever you open an Amazon, previously if you buy more mobiles, it will show the mobiles, new mobiles. So if any person who buy more electronic appliances, so those will be shown. So that is nothing but the segmentation or simply clustering. They divide the customers into groups. So based on the groups, they will show the items. So that is the best example for unsupervised. Reinforcement learning means it learns by interacting with the environment. For example, like robotics. So like instructions, it will follow like instructions. Of course, it is also having some reinforcement learning, also having some algorithms. But basically we call it like an interactive learning. And what is the main purpose behind this supervised, unsupervised, or reinforcement learning? So we have the data, we have the algorithm, we have the model, and we have the predictions or decisions. So any AI algorithm works in a similar way. So first we should have the data. Without data, it is not possible. And we should have some algorithm. And from the algorithm, you build a model. So by using this model, we can able to predict or make the decision. So coming to applications, we can use machine learning everywhere, like recommendation systems. What I told earlier, like Amazon and Flipkart is using recommendation system. It recommends the products based on our buying habits. And sentiment analysis, fraud detection, and also we use in self-tuning industrial systems. So not only these, most of the real world applications we can able to solve with machine learning algorithms. Only the limitations with the machine learning algorithms, it requires some large data. Okay, so if you have very small sample, for example, if you are working with any new disease, so like any one type of cancer having, you have less samples, it is very difficult because the name only indicates learning. So machine learning or deep learning, the word common is learning. So it needs learning. For that learning, you need more data. If you have less data, it is difficult for your machine learning algorithm. So that is one of the limitation for the machine learning. That means we should have some large data, then only it works well. Coming to deep learning. Yes, deep learning also very much important. And if we want to do research, so we have the latest technologies like cloud computing, deep learning, and now quantum computing comes into the picture. We can mix these. That's why I'm telling from starting point of view, why I'm telling that is, if you write a paper on only one topic, it is difficult to accept. So if you match the technologies, then definitely that is called a new thing. Of course, that may be succeeded or you may be failed, but if you tried, so if you merge any new techniques like blockchain, in the blockchain also you have the data. So in that data, if you try to use any AI techniques, then that definitely gives some new thing to your paper, and it will be there may be more chances to accept of our paper, and we can able to complete our research work also very fastly. Of course, even though after PhD completion also, we need to write the papers. If we write on the new technology, there is more chance of acceptance. Coming to the deep learning, it is a specialized branch of machine learning that uses multi-layered artificial neurons to model the complex patterns in high dimensional data. What does it mean? Simply, the machine learning task is very simple. So if you have the large data, so the main drawback with the machine learning is feature identification. If you have some 100 or 200 features, it is difficult for your machine learning algorithm to identify the best features. But in deep learning, it can able to pick up the features by its own. So there is no need to apply any feature selection techniques. It will automatically select the features. That is the main difference between the machine learning and deep learning. And of course, why it is powerful, I already told you. So it mimics the human brain's neuron connections. That means it exactly works like our human brain, capable of feature learning. These two are the difference between machine learning and deep learning. And the term neural network came from our neuron only, human neuron only. From that only this word is used. So in deep learning, we have several techniques. Of course, I'm not going into detail. Just we are seeing only one slide for each advanced technology. So convolutional neural network, especially if you have the images data, if your input is the image or video, CNN is the best choice. And if you are working with the natural language, that is text data, speech, then this RNN, LSTM or transform work better. And if you want to generate the more images, for example, less samples of data, as I told, if you have less samples of data, you want to generate more, we use GAN, generative adversarial networks. GAN also we call like generative AI. So generative AI is also one of the latest technique, especially in machine learning and deep learning. Now, generative AI is the new technique. So if any new person are trying to working in this area, so they are trying the last paper or one of the paper with the generative AI, not only ML and DL. So you can add one more paper with generative AI. So because that is also the latest concept. So that comes under deep learning only actually. Of course, we have the new terminologies we can use, but basically that is the part of deep learning. And coming to the applications, large number of applications we use in the face recognition, medical imaging, autonomous vehicles, and as I told, language translation, chatbots, ChatGPT. Chatbot is nothing but ChatGPT, best example, voice assistant, and other fields like drugs, weather prediction, music creation. So number of applications are there, and mostly most of the real world problems can be solved with these deep learning algorithms. Even the machine learning may not solve if you have the image data. It is not possible to handle properly with the machine learning algorithm. If you have video data, it is not possible. If you have text data, of course, we can apply the algorithm. But the best suited is the deep learning here. Again, what is the challenge? Exactly, either machine learning or deep learning, the learning is common. So what it learns, it will learn from the data only. If you give the data, first it learn, then only it will give answers, whatever the question you ask. In the learning, if you give very less data, how it learns? So definitely deep learning also needs huge data with the computing power, and there may be some chance of ethical issues here. Okay, we will discuss the ethical issues also in the later part. So this is the relation between the AI, ML and DL. I am not going to enter into the detail, but artificial intelligence is a broad term. In that, machine learning we call like a subset of AI, and deep learning is actually a subset of ML, which contains the algorithm and more powerful tasks we can able to do. So that is up to now we discussed supercomputing, artificial intelligence, and now quantum computing. I can various topics in this FDP about the quantum computing, but what I am going to suggest you is just you don't stop here. You just go through these topics and start the research. See, in the first day of learning, every topic is new to us. Okay, so I am also not expert in quantum computing. I just started recently attending some FDPs. So I am doing my research in machine learning and deep learning and generative AI. That is my research area. But on the day one, I too don't know anything. So of course now machine learning is very popular. Even in our curriculums also machine learning came into the picture. But I started the machine learning learning in 2018 to 19. At that time, actually, I participated in various FDPs by Dr. Ravikiran sir in this PBSC the college also, as I already told you initially also. So at that time also, they conducted various workshops in AI and machine learning. At that time, this is a new term. Still in 2018 and 17 only, they started these AI workshops. Okay. So now we will coming to quantum computing. So a normal computer works like a light switch, and each bit is either 1 or 0. That means we called it like on and off. Okay, as I told, I explained with this simple example only because you already learned concepts. But now I am trying to summarize all this. So now what is quantum computing? You consider a normal computer, it has two options, 1 or 0. But quantum computing works like a dimmer switch plus some magic. What is it? It can be on, it can be off, or it can be both at the same time. So as I told this example from the starting onwards, you are in the first floor, you are in the second floor at the same time. So when you listen, when you see that example, you may wonder and you think, okay, this is not possible, this is impossible. So, but still, we have the chance between the on and off. Simple example. I will give one more example. If you just coined a toss, okay, what you will get? Head or tail. But in the air, you have chances for both head and tail. So that comes into the picture. That is quantum computing. You work there. So you just coined a toss. So now you see either head or toss after some 5 to 10 seconds. Within 5 to 10 seconds in the air, you can see both the states. Now the coin is in both the states. Exactly. So in that way, so if you consider that point, this quantum computing comes into the picture. So you can see it has multiple states, not like only on and off. It has multiple states. So quantum computers can explore many possibilities at once instead of checking them one by one like a normal computer. So this is the major difference between a normal computer and the quantum computing. It can able to explore many things at a time, not one by one. So I have given very basic examples like tossing a coin or switch or whatever it may be, like lift, whatever it may be. So if you come into the deeper analysis, more mathematics involved in the quantum computing actually. So if you have only head or we have only tail, so we know the probability, we can easily write it 50-50 chances like that. But if you are saying both may be also possible, you need to have multiple states, not only two on or off, head and tail, not enough. So think of like, you will see like this. This is also one of the example. So image analogy, you consider a image, for example, classical versus quantum computing. So in a classical computer, if you have a maze in the sense you have the starting point and you have zigzag path, and finally you have the end exit. So in a classical computer, one path at a time you can go. Okay, you will try first path. If you fail, go for second path, third path. Like that you can go. But in a quantum computing, all paths can be explored at a time. That means simultaneously all the paths can be explored. So by, for example, if you listen this, it is very impractical. But if you consider that keen observation, it may be very much useful in number of the applications. So that comes into the picture in the quantum computing. So here you see, so it can explore, all paths are explored simultaneously. So that is the advantage. If you explore one by one, it may take a lot of time. If you explore all at a time and if you find the correct path, then it is good. But it involves more mathematics. You see here one solid line I have drawn, normal computer. So here I had only one line. So generally you need less computational power and less mathematics. But multiple at a time means you need to learn more mathematics. You need to use more equations, more math you can do, more operations you need to do. So that's you need to learn, then you can able to enter into the quantum computing. Okay, so this is also one of the examples where I shown orange path is nothing but the classical computer, which is exploring one path at a time. But purple path, it explores all possible paths simultaneously. That is the difference. So here, coming to the definition, first I just try to tell what is quantum computing in layman terms. That means even though we don't know quantum computing, so actually what is it? So while attending some FDPs also initially also, what is this word? Of course, it is a physics word. That is the problem. If you are not related to the physics, we may always confuse, okay, this is not related to word. The word, when we listen quantum computing, so yes, exactly, the physics professors have more knowledge on it than us. That is true. If you want to work on this, we need to learn more from them. So, but the definition is very simple, as I told with the examples like coin tossing, whatever it may be. You understand the basic concept. So in that, what we are doing, why we are doing, we can do by learning all those things step by step. That is not a difficult thing. So what is the definition? So it is simply computing based on principles of quantum mechanics. So that's why I use the word physics, quantum mechanics. So generally the physics people have more knowledge on it. So if we have the basics about quantum mechanics, so you can understand quantum computing very easily. So instead of the bits in the quantum computing, we use qubits. Like in the bits, we have 0 and 1. And in the qubits, we have both the 0 and the 1 and both at the same time. We call like a superposition. Of course, because this is the last session, you already know about the quantum computing basics. I think you listen these words like superposition, etc. Okay, so what is superpositions? Yes, qubits can represent multiple states simultaneously. So that is the, see, whenever I am defining, finally we stop at one place. What is that? Simultaneously, parallelly. Multiple paths are there. We can able to go parallelly. So switch is there. We can able to parallelly on or off. Lift is there. You can able to parallelly in one state, one floor and second floor. So that is the superposition. So simultaneously, you can having the multiple states. So coming to the power, it can able to solve certain problems which are exponentially faster than the classical computers. That means the quantum computing, when it is useful, that's we are talking about. So if the problem is very, very complex, that means certain problems that are exponentially faster and very complex, then you apply this quantum computing. For simple traditional jobs, there is no need to apply quantum computing. Of course, as I already told you, like machine learning, deep learning, you compare. So when you apply deep learning, you have only Excel data set. There is no need to go to deep learning. If you have the videos data, if you have the image data, then there may be a chance of your deep learning algorithm give better result. But you have a simple Excel data, first you must try with machine learning algorithm, because machine learning algorithm can able to perform well for simple Excel data. So here also, there is no need to go for quantum computing for even a small task or simple task. There is no use. Of course, in the learning stage, quantum computing is very new. Initially, we need to learn the basic with the simple task. That's why in the examples, we may learn with the simple tasks. But in practical, if you apply quantum computing with simple tasks, there is no use. Okay, so if you have the more complex problems, then you go for the quantum computing, then only you get the benefit. So coming to the status of quantum computing, so I am discussing this from the starting. Still, it is in research and early development stage, but progressing rapidly. So it is still in the process of development stage. So as I told, if you consider practically, so it may not be possible 100% implementation. It may not be possible. Of course, we have some tools for the quantum computing also, but like machine learning, deep learning, nowadays everyone knows the algorithms. So that much aware is not there. So still some research is going on this quantum computing. But coming to the applications, we can use everywhere. Like cyber security, we can use. For example, today's encryptions can be broken by future quantum computers. That means you can make your systems more secure because it is having the multiple paths or multiple choices. So it is difficult to break it. So in that way, you can use it for security. So it can able to create unbreakable codes because multiple options are there. So you create multiple options with the security. Definitely it is difficult to break for the others. And healthcare and medicine, you can use in drugs treatment. So like machine learning and deep learning, we can also use quantum computing. Transportation and logistics, so you can find the best route among the millions of options like Google Maps. You can use it, can be useful for the airlines and delivery companies and traffic clearance. So like that also you can use. And the AI, as I already told you, you can mix this quantum computing with the AI. So quantum computers can train AI models much faster by handling the huge data sets. So in the AI, machine learning, deep learning, what we discussed, so they have large amount of data set. So if you use quantum computing, because the data is very large, if you can able to learn or train in very less time, so definitely that is useful. So if you mix that AI concept or machine learning or deep learning concept with the quantum computing, so there may be a chance of getting the better results, and that can be a new topic, a new innovation. You can able to do research on that. So coming to the topics what we discussed. So what is advanced computing we discussed, supercomputing we discussed, applications of supercomputing we discussed, machine learning, deep learning, applications of quantum computing. So these topics, whatever you learn in the this 4 days FDP initially, so just I am coming to recap it. And this is the quantum computing diagram. Of course, I'm not going there. So parallel programming, what is parallel programming? Of course, high performance computing involves parallel programming. So what is parallel programming? It breaks the large problem into the small tasks and you can able to do simultaneously. What is the advantage? Speed can be improved, efficiency can be improved. So it is widely used in high performance computing. Of course, what is this parallel programming means? It is also part of supercomputer. That's why I'm adding. So in the supercomputing, we also call like high performance computing. So if you use the parallel programming, it is very much useful. So it is generally used in high performance computing and AI training and scientific simulations. Like weather forecasting, we can use the best example. Millions of calculations can be done in the parallel for accurate cyclone prediction. So simply what is parallel programming means? Splitting the tasks for faster results, like distributed computing also. Distributed computing also, you have the multiple tasks you can able to done parallelly and you can able to increase the efficiency. And cloud computing, these are the other advanced concepts. Okay, whatever we revise, so I am adding some more advanced concepts. So cloud computing is also very useful because if you don't have the storage, so you have the popular storage providers like AWS, Microsoft Azure, Google Cloud. So Google Cloud, mostly we know that, of course. So we may think like that, okay, we may not be used, but most of the companies are using this cloud, maybe for our daily use. So that much storage is not required. So that's why generally there is not a chance for us to buy these cloud computing storage, but the companies use this Google Cloud or Azure or AWS, so that can be useful for them. So what is this cloud computing? Okay, what is this cloud computing? You just keep aside, but how it is useful for us? Simply giving their components to rent to us. Okay, so we are just going for a new computer with high hardware, so it may be in the lakhs, but if you go for a rent, generally it is very less. So that rent can be given to the Google in the place of Google Cloud. For Azure, if you are going for the Azure, you can give it to the Microsoft. So these are nothing but service provider. They are giving their processing and high performance computing to us on a rent basis simply. But generally, we don't need that much processing power. That's why most of us may not have necessity to go for this cloud computing. Okay, that means no need to pay the money and use these resources. But the companies need this. So examples, of course, freely some are available for us. Google Drive, you consider Google Drive, the storage is available. Okay, up to some point it is free. So if you open your Gmail, you have Google Drive with the capacity of 100 GB, up to 100 GB free. But if you are using more than 100 GB, so it is not possible to use freely. So you need to pay some amount. See, so I am using 200 GB. For that, yearly I will pay like 2000. Okay, so not monthly, you can pay yearly once actually. So if you pay like 2000, 1500 for that, so you will get 200 GB. So why I need 200 GB means, so while doing some research and writing papers, so I have a lot of image data set in my Google Drive. Okay, so all those data, if I remove, I don't know whether in future I may write one more paper in that data set. So if I remove and keeping in my system, it may be difficult because I will do all my deep learning algorithms in Google Colab, you know. So you know, if you want to execute your code in Google Colab, your data sets must be in the Google Drive. So that's why I loaded a lot of data sets in my Google Drive, that is full 100 GB. So later I have taken one more 100 GB. Now I am using carefully. But for that I need to pay some 1500 rupees to the Google. So that is one example, Google Drive. Like we have the Dropbox and Office 365 also, we have the Drive. So you can pay and you can use. Of course, you can also buy a hard disk. The problem is if you want to execute the program from Google Colab or any other tools, it is not possible to do it from the hard disk. Every time you need to put your hard disk, copy it, and you can able to do. But the advantage with this cloud computing techniques is they are not only providing the storage, they are also giving the technologies. So like Google is giving the Google Colab for us. So in the Google Colab, you can able to run any deep learning algorithm without installing anything. Even though you are not expert in machine learning and deep learning, you are no need to install a single software. You just need only a Google Chrome browser or Edge browser, any browser. So you have the browser, that is enough. You are a programmer in machine learning and deep learning. You can write the program. So you can execute it. In the drive, you store the data and you load it into your Google Colab and you can execute it. So how simple it is. If you want to work offline, for example, so how our Python programs can be run in the system, you need to install the Python software. But if you want to execute machine learning or deep learning programs, you need to install several packages. Several packages. Some packages also show errors while installing. Installation only takes a lot of time. But if you go for the Google Colab, what happens? So it will have Google Colab, you have Google Drive. So you buy 200 GB or 300 GB. If you are writing a paper, so that year you buy 200 GB. You keep all your PhD work and data sets in your Google Drive. So yearly 1500 is not a matter when compared to a PhD work. So you can able to, and Google Colab also monthly available, monthly 1000 rupees. So if you want to apply any deep learning algorithm at that month only, you buy and you execute. So like that, we have more computing power in our hands. That is the best example. So I'm not going into the cloud computing deeper way because we have different ways this cloud computing can be available. But I am basically here telling the applications. Okay, so as we know, we can use the cloud computing, these services in your laptop, mobile, or server, anywhere you can use. What are the benefits? Just now I explained all the benefits like scalability. You can expand the resources instantly. Now I give a best example. You have freely 100 GB, you can go up to 100 GB. If you add one more 100 GB, you can easily add up. So cost efficiently, pay only for what you use. Collaboration, you have shared the data globally, you can just give your drive link. So okay, because why I'm telling only Google Drive example is everyone know that. So but you coming to the big companies, they may go for Amazon AWS, so Google Cloud, more storage, so they can use that. So every day we use also, we can able to use these apps like online apps, all these things also we will get on a rent basis. So major benefits is scalability. It can they are scalable, you can expand easily, cost efficiently. That means you can pay whatever you use, and collaboration means you can work anywhere. So if you have Google Colab, if you open in any computer, you open your code and you can execute. If the data is in your Google Drive, you just log into your Gmail and you can able to execute it from anywhere. For example, if you have your PhD work in your hard disk in Drive D, so it is not possible to access if you are out of station with another computer. But if you store your data in Google Drive, so wherever you go, you open and you can compute your programs and you can complete your task. So if you go for a rent, that is the advantage because that is available virtually online. And one more advanced technology, GPU programming. So everyone knows about GPU, CPU and GPU, we know it. So GPU is the more powerful with thousands of smaller cores. This GPU is basically designed, yes, if you have a gaming laptop, so that is already equipped with GPU. So graphics and gaming. Now, this GPU can also be used in machine learning and deep learning algorithms, because deep learning algorithm, if you go for a large data set with more size, if you have GPU, that will be finished very fastly. And GPUs also plays a vital role in parallel processing, and these are much faster than the CPUs for certain tasks. Example, NVIDIA, we know NVIDIA CUDA and Tensor cores we can use. So which can able to use all these systems. If you have GPU in your system, you can able to execute all these programs fast when compared to the previous ones. So these are some applications of GPU. We can use in AI and deep learning, scientific simulations, graphics and gaming. So in some gaming, video games, you need a better GPU, then only it will work. So high performance computing also. Examples I already discussed. So that is about whatever the advanced technologies. So whatever the topics I discussed, these are all advanced technologies. So if we want to learn any new technology, these are all the choices available for us. Like it may be a quantum computing, it may be high performance computing, supercomputing. But some concepts are very difficult to learn. For example, like quantum computing is a very new one, and the problem is that is still in the process of research. There are no much conclusions available. Even if you open the papers also, so there are no solid evident conclusions available for the topics. So that is the good stage to start the research actually. But again, you need to learn more concepts. Then only you enter into the quantum computing, because you need to have more knowledge on quantum mechanics and basics. Then it is easy. So if you combine multiple technologies, so that is also I am telling from starting point, AI, quantum computing, and if you combine cloud. So if you combine these three, then you are very faster, very smarter, and more scalable. So that is nothing but advanced. So you have two advanced technologies. If you are able to combine, what happens? You are the faster and you are the smarter. So edge and IoT computing, of course, we are not discussed the IoT, but IoT also very emerging trend, you know. So automation and robotics, personalized machines. So there is no end for future trends with the advanced power. So whatever the topics we discussed with this, so there is a more scope of the future with the new technologies, and there is the more chances of growing these powers in multiple times, the processing power is increasing multiple times. So, and of course, cost is also high, but when compared to previously, even the more computing power is not available for a individual computers. Now, individual computer can also able to perform, for example, if you have i7 processor with multiple octa core process, it will come, it can able to do lot of things. Earlier, we know core to dual core systems, we know how slow those are. So whatever we discussed is simply a summary recap of advanced technologies. Of course, whatever the concepts we studied or discussed in this FDP from the starting onwards, I just revised. So coming to the ethics. So now we are smoothly moving on to the ethics point of view. So with great power comes with great responsibility. So we have the power. If we misuse, then it's not a good thing. Of course, you have a chance. If you have a power, you can misuse. That is possible. So that's why we should have some ethics. So that ethics learn that don't misuse the power. So your power means not that power, computational power point of view we are talking about. So advanced computing brings huge opportunities. We discussed until now, but also serious ethical challenges are also there. So that's why we need to be for responsible innovation. So if we innovate something, but that should be also responsible. That means you should have some ethics while developing anything. So unethically, you can't do anything. So first we will take an ethics in AI. We discussed AI now. So AI is not neutral. That means it reflects the values, data, bias of its creators, etc. So it is not a human, you don't have any common sense. We see in like Robo movie. So it is not having the common sense. You can misuse also. In the movie Robo that is shown. So you give the green chip, it works well, and if you give the red chip, what it will do? So it can harm anyone. So societal impact is also there in the healthcare and hiring, finance, education. So they can misuse, that is chance. Because of that, there may be potential risks, unfair treatments, misinformation, deep fake. So these are all the possibilities, and ethical considerations ensures this AI services fairness, accountability, transparency, and human well-being. That means if you use it in a good way, so then only that is useful for this world. Otherwise, if you use unethically, for example, face marking, some people are there. So they use face marking also, and they put some photos in the internet. So they are using AI in unethically or in a negative way. So that should not be done. So ethics, no one will taught us. So as a human being, so we should have some ethics. Okay, because it is very difficult to find. If you do unethically, it may be difficult to find. In every sector, it is not possible to find fastly. In some sectors, they can identify fastly, but in some sectors, it is not possible to find. For example, if you apply face marking and put some photo in the Instagram, so it may be difficult to identify because a lot of people are not working in this area. Of course, cyber teams are also there. But if as a technology developers, if we follow ethics, so that resources cannot be wasted. So we should have, so in the AI point of view, we should have that ethics. So we will see what is the bias and fairness. Okay, with some more detail. So AI reflects human data. So that means biased input equal to biased output. So we have some examples actually. Okay, we will see. Facial recognition bias. So in a mid study in 2018, error rate for dark skinned women was 34% versus less than 1% for the white men. So the real impact, what is the impact of this error rate is, so wrongful arrests in the US. For example, by using the face, they may arrest some people, but with the AI, they cannot find the correct people. So that is the drawback. So that may be happened. That is one of the example, and hiring bias also. So like in Amazon's AI recruitment tool, so downgraded resumes containing the word women's. That means they are giving more chances to the men. These are the some cases happened, and those examples I used. Healthcare bias also. A widely used AI system in US hospital underestimated the illness severity in the black patients because the training data was biased. So that means in the US, actually, those types of the problem, they may have the problem of black people and white people. Of course, in India, those type of things are not there. That's why you see all these examples, these are happened in the US. So that is biasness. Bias in the sense, if you train your data more biased to your required people, then other people may get any problems with that. So that can be happen because AI system don't know. It is like a program. Whatever you give input, based on that, it will produce the output. That is biased input is biased output means if you give wrong input to your AI machine, it will give wrong output only. So it don't know anything. So who know? As a human being, we should have an ethics and ethical need. What is that ethical need? Build diverse data sets. That is we are talking. So while preparing the data sets, also we should be ethical. For example, we have several data sets in the internet like Kaggle or UCI repository. So we don't know the data is correct or not. We just download and we use for our research. For example, if you download some hospital data, you are using for your research, are you 100% sure that is correct? No one give 100% surety, but still we are using the data. So that means the person who uploading the data so have some ethics, then this type of problems may doesn't happen. Similarly, audit AI systems, so it is not possible. Actually, ethical need means, so whenever the cyber crime is there related to AI, then they may book a case and they can go into that and they can resolve it. But every time it is not possible. So we need to have some insurance and transparency and fairness. So in each and every AI usage, then there may be a chance we can able to find any negative in this. So there is a more chance of unethical use in AI technology, data privacy issues, one more issue. So AI tries. Hello, are you able to hear? Yes. I think I'm. Are you able to hear or any problem? Because yes.
Yes, sir. Yes, we
Okay.
can hear you.
Okay. So I think it may be disconnected. So AI thrives on data. That means data is the base for AI system. It collects massive personal information. So like even our Aadhaar data also collected. So we are listening those issues. So there is no data privacy. So that data privacy issue is always there. So corporate use. So tech companies like tracking the online behavior for ads and profiling. So as we will see some ads based on our profiles. So how that is happened, we are getting some calls. Okay, so we will get regularly some calls like Bajaj Finance, so and so calls we are getting. How these calls are getting? Because they just given our data and our privacy is not there. So without any permission we are getting the calls. So these type of data privacy issues are also there in AI systems because AI system works with the data. So what is the ethical need here? So protect the individual privacy and consent you should take. If you want to use any person data, we need to take the consent. So in research we are doing that. For example, if we are using some algorithm proposed by some researcher, we will cite that paper. So if we want to write some literature review, we are citing that paper. That means what we are saying. So we are taking the consent from that author, of course. No need to take consent for each and every paper, but we are citing means, so we are telling that this is not our, so their work we are here using. Like that we are telling. So that is the ethics. So researchers mostly we will use it, but the attackers may don't have those type of the ethics. So autonomous systems, who is accountable? So AI-driven systems act independently. So that means anyone can use the AI system. That can be in a positive way or negative way, like self-driving car. If an accident happens, who is to be blamed? Manufacturer, programmer, or passenger? Okay. So then there comes some challenges and issues. Okay. So Tesla car, we know driverless car. So if accident happens, so manufacturer will take the responsibility or that program is designed. Of course, programmer is also part of the manufacturer. So programmer we can blame, or the passenger, who you can blame, we can blame. So these type of questions may allow. So these type of questions can be resolved because these are the possibilities with the AI systems. Military drones, autonomous weapons may take life or death decisions without human oversight. Similarly, healthcare, robotics, so AI making treatment choices. Who answers if something goes wrong? So that also we have seen in robo movie. Some operation can be done by that robo. So if that is success, okay. If that is failure, so who will responsible? Because the machine is not having intelligence. Of course, artificially it is more intelligent than us, but it is not having the common sense. So there is a chance of doing the mistakes. So what is ethical need here? Clear accountability frameworks and human oversight. That means the who is accountable should be defined. Then only there are no ethical issues. And job displacement and AI. So automation impact is there, like AI, robotics taking over routine and repetitive jobs. So we discussed this also. So for example, in the figure, we have the 3 workers. That job can be done by a single AI or robot. So what happened is, so the problem is there here. But what is the alternative means? We need to, what is the ethical need? Reskilling workforce, preparing for human AI collaboration. That means you can enhance more skills. So you need to update. So as I told, you need to learn how to use AI tools and how to make the company's jobs easily. And you can able to prepare for human AI collaboration. So manually, if you do in the same way, no one can hire you. So that reskilling is the requirement. We need to implement that, then only it is possible. And coming to this has also I discussed here in the recruitment in the US that is happened. So more male CVs are taken instead of the women in Amazon. So the problem is the program is written like that. So what happened is most of the male CVs only taken because they depend on that one of the AI hiring program they written, but that mostly trialed on resumes of the male. So what happened? So most of the jobs go for the men. Later they identified and they asked, so they rectified. That is happened. So that is one of the example. So now that is about the ethics in supercomputing. And now coming to, sorry, that is about the ethics in artificial intelligence. Now coming to supercomputing. What is the role of ethics in supercomputing? So why ethics? Supercomputing means, as we already discussed, more power. So it can be used in defense or climate or space research. So very high cost energy infrastructure requirements must be there. So only, yes, now the problem is, for example, if you consider America, they may have more supercomputers. So some countries may not having those supercomputers. Then what happened? Only a few countries or organizations can afford them because of the more cost. So who benefits? Only the rich countries can benefit. So other countries may not get benefit. So then what happened? Only the countries which are having the more money can able to do some task. So the countries which are having not more money may not able to do the task. So that is one problem here, of course, that is always there. Examples we discussed about the supercomputing. And what is the environmental impact of supercomputing? So energy is taken more. So energy hungry. That means lot of electricity power is wasted. Yes, of course, the computational power is more, but it may need more electricity. So these resources may be more. Cooling needs because of high computing power. So that heat is produced. So we need both more water, tons of water we can use for power cooling. Carbon footprint, high performance computing contribute to global emissions. Definitely global concern is also there. That means sustainability comes into the picture. So we have some examples. Data centers worldwide, you consider 2% of the global electricity consumption is used by the data centers, like Facebook data center or Amazon data center. So data center only consumes 2% of the global electricity. So then here what is ethical need? develop a green computing practices like renewable energy and efficient cooling. So that means it is not telling like that, okay, stop the supercomputing because of this problem. So that means ethically we should think like developing the green computing practices. That means renewable energy, even though you are using the energy, more energy, so it can be generated automatically. You can use the solar systems. I am telling the example like that. Renewable energy, if you can use, then the energy is not wasted and still you can use your supercomputers. So that means simply here what is telling ethically means don't waste the power. If you have the power, so don't waste it. You try to use whenever necessary only. Otherwise, don't use it. And defense and military use also supercomputing. We already discussed this. Coming to the ethical concern, so risk of global arms race in supercomputing. That's I am telling you. So it should have the weapons development. Supercomputing can be used in weapons development, rocket development. So if you use in a ethical way, that is good. For example, we recently listened that nuclear Pakistan is also having the nuclear. They are saying that we will throw the bomb. So that is not the ethical thing. So the power is in their hands. What they are doing, they are using it in a negative way. So they should have the ethics. That's we are talking about. So we should have the ethics and we should use it in a positive manner, not in a negative manner. And coming to inequality of the access. So yes, again, this is also same example. Because of the high cost, all the peoples, for example, all the countries may not able to afford and may not able to use. So you directly see the example, top supercomputers dominate global ranking like Japan, USA, China. Those are having the top computers, not all the countries. Okay, so they are having more domination. So they are only having the access. So what is the ethical question here? Should advanced computing power be shared globally for common good? So that means instead of only using by them, they can also share to the other countries ethically. That is good, but that may not be possible. And supercomputing for the climate change. So in the Japan, Fugaku, I already discussed it. They use it to simulate a COVID-19 virus spread and evaluate mask effectiveness. That means like COVID. So what they have done means, so they spread some virus, not a virus, they spread it and try with the mask. That means they have done one experiment. So like that supercomputer model climate change scenarios also we can use it. And what is here ethical use? So in the ethical point of view, technology serving humanity and environment, not warfare. That means if you use it for the war, so that is not the good. You can use it for the environment change, environment friendly. You can make the environment in a greener way. That means you can use it in a proper way, then automatically it will be happen. And now coming to the ethics in quantum computing. So quantum computing, we already discussed dual nature. Okay, it can be in both at the same time. So what is the ethical need here? We can ensure the responsible research, fair access, and global cooperation. That means we can use it in a positive way. Examples, what is the positive way example means? Drug discovery, you can use optimization. In logistic, you can use finding the best path, we discussed. But what is negative? Breaking the crypto security systems, as I already told you. So it has chance of multiple paths. Okay, you can use that and crack passwords. There is a chance. So if you use for that purpose, so then what happened? That is the unethical. So we should use in a ethical way for the positive things only. And of course, these are all related to that only. Access inequality also again coming to the picture in quantum computing, because so here also developed countries only can able to use this. So US investing billions in quantum computing R&D actually. Because of these multiple states, they may introduce new weapons. That is the idea. Many investees in developing countries have no access to quantum machines. So the top countries can invest more and they can able to find new innovations that can be useful. For their country only. So they may find any new innovations, and if they give for the whole world, that is good. We are saying ethically, but of course that may not be possible. So what is the risk here? Unequal global power. So same, whatever the advanced technology, the same thing happened. So whatever the country is having the more money, they will invest more and they will find the new things and they will always use for their country only. But ethically, what we are telling is that is the dominance. So that is not good that we are talking here. So again, quantum supremacy race. That means in Google 2019, they claimed quantum supremacy. That means they solved a problem in 200 seconds. That would take classical supercomputers 10,000 years. So they claimed that, so actually the problem which can be solved in 10,000 years, we solved using 200 seconds. Google claimed this in 2019. So in 2020, China announced that, so they have some Jinghang quantum computer which achieves supremacy in photonic computing. That is one area in quantum computing. And similarly, IBM's also they challenged the Google claim, saying classical systems could solve it faster than reported. So that means whatever 10,000 years they said, okay, that is not the correct. They can also even solve in less time. So what is the lesson from all this means? Global competition for dominance arises ethical concerns about all these things. So everyone is dominating using the advanced technology. So that may be threat to the world that we are talking about here. So what is the key question? We here this also we discussed. Who is responsible when advanced systems fail or cause harm? Okay, who is responsible? Like self-driving car or supercomputing or quantum computing. So then what we will need here, clear accountability frameworks we should have. So that we discussed. So we have some transparency like black box problems, what are the risks we need to identify. And we should have some ethical needs like build explainable AI. What is explainable AI? XAI is also simply, it will tell each and every point why this is happened. That is explainable AI. Actually, we have XAI algorithms like Sharp and Lime. What they will tell how your deep learning algorithm applied and how the results are given. Is this correct or not? That means the process. Okay, simply you apply the algorithm, you will get the result. But the process they explain clearly. And now coming to environmental impact of supercomputing, also one of the issue. So now coming to see the difference between ethics and innovation. So what is innovation? So you may push for the faster AI, powerful supercomputers, quantum computing. So competition between the nations and corporations. That is the innovation. And ethical concerns means we discussed bias or misuse, unequal access, environmental cost. These are the ethical concerns. We should have balance between innovation and ethical concerns that we are talking about. So innovation must go hand in hand with ethics, regulations, and human values. So finally, after this ethics and innovation, what we need to tell is technology should serve humanity, not to control it. So we need to have the ethical guidelines. Advanced computing means powerful but not high risk. If it is high risk, what happened? Everything will be collapsed. So without guidelines, what happened? There may be the possibility of whatever we discussed, bias, misuse, inequality, etc. So guidelines, if there are some guidelines are there, so someone is accountable and everything is transparent, then it is good. So this technology is developed for the benefit of the humanity, not for the harm. So that is the need for this technology. So IEEE always there. IEEE has some ethical practices. So IEEE given some global framework for responsible AI and technology, of course. So some IEEE is an organization, even though it gives guidelines. So that depends on the humans and the persons who are using the AI or technologies. It is not possible for the IEEE members or IEEE partners to check and every person is using it in an ethical way or not. But they designed some principles based on the privacy rules they formed, security rules formed, transparency rule formed. So like that, some rules are they formed and this can be implemented worldwide. And similarly, so we have the first global framework for AI ethics that we called as UNESCO, UNESCO in 2021. So it will tell what are the human rights and dignity. So here, how to use the AI. It can give the guidelines for transparency and explainability. and it is adopted by the 193 countries. That means while using AI, we should have some ethics. That means if you use in an unethical way, there may be a chance that you may have some problem. Okay, if anyone identify you, you may have some problem, and this is adopted by 193 countries. So similarly, Europe also set some laws for this AI. We call it as EU AI Act 2024. So this is the world's first AI law. That means, what is this means? If you have some like attackers, whatever are there, they only face these types of problems. So what is the goal means? Build a trustworthy AI while encouraging the innovation. So of course, in India also we have some cyber laws and cyber security team is there. So if anything happened unethically, they can find and they can able to find that person, and later that person may be having some problems with them. So like that is already there. And India's Niti Aayog, which is responsible for AI. So it focus on healthcare, AI for disease detection, agriculture also they will use crop monitoring and pest control, education, like personalized learning platforms, smart cities, mobility, all these. Ethical emphasis also, this responsible AI aligned with the equity, inclusivity and transparency. That means because this is handling by the government, they will see all these ethical issues. Okay. And coming to corporate ethical initiatives. So like Google also designed some AI principles, Microsoft even, IBM, OpenAI. So all these have some framed some guidelines for ethical rules. But what is the problem is we are using the technology, not the Google or not the Microsoft. So just the develop, but the persons who are using should have all these guidelines. We should have some ethics, then only it is possible. So ethics must be built into technology, not added later. So frameworks, because all these frameworks provide the trust, fairness, accountability, and sustainability to the users. And global, national, and corporate collaboration is also essential for using the technologies in a ethical way. So these are the frameworks we discussed. So ethics in advanced computing means simply shared responsibility, not even a single country. So that's why everyone trying to frame these rules. So coming to the summary of the key ethical issues, what we discussed till now. So in AI, we have like bias, privacy, job displacement problems. In supercomputing, environmental cost, inequality, these are the problems. In quantum computing also, breaking encryption, dual use risks. So these are all the issues, okay, put in one slide. In cloud, data privacy is there, high energy demand is there. So in the future trends also, these requirements may be there. So and what are the opportunities and risks? So opportunities means we can use our advanced technologies in healthcare, climate, education, smart cities. Those are the opportunities. And what is the risk? Again, the same inequality use, unethical use, these are the risks. So we need to create a balance between this progress and responsibility. So then only we can able to use this technology in a correct way. So coming to, okay, we discussed that advanced technologies and some ethics related to each and everything. So should AI be allowed to decide court biases like bail and sentences? So if we can give the permission to that, so the advantage is speed, consistency, because the number of cases are pending in our courts. But the problem is lack of empathy and hidden bias in the data, because that will only work on the based on the data. That means simply at the end, I'm just adding a questions that which are possible to automate. Similarly, should quantum computing encryption be restricted only to governments or open for all? So again, the advantage is national security and control. And the cons are transparency, fair access, innovation. So these maybe have always both advantages and disadvantages. Okay, so that is the main balance between the usage in a proper way and a in a improper way. That is nothing but the unethical way. So as an educators, researchers and professionals, so we teach responsible computing, encourage the fairness and inclusivity, and also ethics is not anti-technology. So what we are saying is, so we are telling that all the drawbacks with the advanced computing from ethics point of view. But the final message is ethics is not anti-technology. It ensures only technology truly serves humanity. That means use it in a positive way, that we are telling. Okay, so that is from my side. So actually I am having the internet issue, that's why. So actually I want to explore more and more things, but having the internet issue, that's why. So I want to conclude. If you have any questions, you can ask. Sir, Ravikiran sir.
Yes, sir. Yes, sir.
Thank you, Ravikiran sir, for giving me this opportunity. But actually today I am out of station. That's why I am unable to spend much more time. Otherwise, I may be there up to 7 o'clock. I planned, but
No issue, sir. No issue, sir. Samrat, sir? Samrat, sir, are you
Yes,
there?
sir. Prashant, you can conclude the session.
We sincerely thank our resource person, Dr. A. Lakshmanrao sir, for his insightful session on ethical considerations in advanced computing. His thoughts on ethics in supercomputing, artificial intelligence, machine learning, deep learning, and quantum computing have truly enriched us. We are grateful for his guidance, and we hope this association continues in future too, sir. Thank you.
Samrat, sir?
Yes, sir.
So what is the next action, sir?
If any participants are willing to give the feedback, we'll switch on the mics and also the video for you. You can speak if you are willing to.
I request some of the participants to give the feedback, please. Viola, are you there?
If anyone is there, you can raise your hand so that I'll able to unmute you. Yeah, from now on, the faculty can unmute themselves and also they can start their videos.
Good evening, sir. Hello, sir.
Yeah, good evening, you're all.
So, good evening, everyone. I'm Viola, Assistant Professor from Andhra Lala Institute of Engineering and Technology. It gives me an immense pleasure to be part of this wonderful FDP. I would like to thank the management of PBSC College of Arts and Science for conducting such an amazing FDP, and the conveners, co-conveners, and all supporting staff for smooth organization. Really, the sessions all are amazing, and valuable insights are given to all the participants. Quantum computing, a new buzzword and the next frontier of technology, offering unprecedented speed and power to tackle challenges that traditional computers cannot handle. The FDP on advanced computing, its application trends, was highly informative and enriching. All the sessions provided a good insights into emerging technologies such as artificial intelligence, machine learning, deep learning, cloud computing, supercomputing, Internet of Things, and big data. All sessions were included with both technical and practical examples. Really, we enjoyed all the sessions by learning new concepts along with their real world applications. The resource persons were really knowledgeable and engaged all the participants effectively through the discussions and hands-on sessions. I would like to thank Dr. A. Lakshmanrao sir for giving session on ethical considerations in advanced computing. It was very meaningful and thought-provoking one. It emphasized the importance of using emerging technologies responsibly while ensuring fairness, transparency, and social well-being. All these discussions really added a great value to the FDP by reminding us that innovation must always be balanced with ethics. Thank you, sir, for your information. Finally, the entire programs are really enhanced our understanding of modern computing paradigms and their applications in teaching, research, and industry. Overall, FDP, including 13 sessions, were highly valuable and provided us a useful exposure to current technological trends. It was really a valuable learning experience. For me, I wish we could all have more sessions like this in future. Thank you, sir, for conducting this beautiful session. Really, quantum computing is a buzzword, and as a faculty, all we need to have a much knowledge on this technology. Thanks for giving us a great opportunity to learn the new technology, which is really helpful for our profession. Thank you so much, sir, for giving me this opportunity.
Thank you, Viola. Anyone from participants? I request participants to give your feedback.
Anybody else willing to give the feedback? You can unmute yourself.
Hello, sir.
Yes, sir.
This is Venkatesh from Parnandra College of Engineering, Narsipur, sir. So it's very valuable and very wonderful section, sir. And these sections are gaining the more knowledge from the latest trends and the latest enhancements of the technologies, and very useful and very wonderful of this feature. And thanks for the thanks for the all the resource persons and the management of the PBC Data. And thanks, sir. Thanks, sir. And
Thank you, Garu.
Sir, this is Manjula from college. First of all, initially, I just want to thank Ravikiran sir and Samrat sir for organizing, conducting, implementing, and completing all the sessions so smoothly and wonderfully. I place on record all the knowledge that has been put by the resource persons from different areas, and all the cutthroat edge computings of the present day have been touched both theoretically and practically. Especially number of insights have been given on quantum computing, which is really going to shape future India, especially for the youth. The sessions not only touch the technical side, but also on the moral and ethical values that are really required. Cloud computing, which is going to have its own importance in the present day and in the future also. Likewise, the hands-on experience that has been given by Satish sir, that was really wonderful. We have really learned how to train the things. And every resource person on their part, they have done wonderful work. And we thank once again Ravikiran sir and Samrat sir and all the management of Siddhartha College for conducting such a wonderful FDP. And we foresee to have many such FDPs from your college, sir. Thank you, sir.
Thank you, Dr. Manjula, madam.
Sir, so I think we can start the validatory session, sir.
Yes.
Now I request Dr. T.S. Ravikiran sir, convener for this 6-day online FDP program, to convey the validatory speech.
Sir, is my video is visible, sir?
Yes, sir, it is visible.
Good evening, everyone. This is Dr. T.S. Ravikiran, Head Department of Computer Science, Parvataneni Brahmaya, Siddhartha College of Arts and Science. I am acting as a convener for this conference. Respected dignitaries, esteemed resource persons, faculty participants, and dear colleagues. Over the past 6 days, we have come together as a community of learners, exploring cutting-edge topics in advanced computing, exchanging ideas, and gaining valuable insights from distinguished experts. The FDP has been a platform not only for knowledge enhancement, but also for collaboration, networking, and speaking new directions for teaching and research. At this juncture, I deem it my privilege to extend a heartfelt vote of thanks to all those who made the 6-day AICTE-sponsored ATAL Faculty Development Program on Advanced Computing and Application Trends a grand success. We are fortunate to have excellent lineup of resource persons joining us from Mr. Priyatham Bollampalli, Senior Applied Scientist, Microsoft USA, Mr. Sivakumar Odugu, Technical Architect, Infosys, Germany, Mr. Pedavanki Pola, Founder, One Shot AI, USA, Mr. Pavan Chalmalasetti, CEO, Data Valley, London, Mr. Prakash Kaja, CEO, Sadrujo Technologies, Hyderabad, Mr. Durga Gadiraju, IT Varsity Incorporation, Hyderabad, Mr. Bharat Kumar Reddy, Gujavarti, Founder and CEO, Pragmatic System Incorporation, Hyderabad, Mr. Deepak Gupta, Founding Director, TUP Make Professional, Private Limited, Bangalore, Dr. A. Lakshman Rao, Associate Professor, Department of IT, Aditya University, Dr. Venkata Sambasivara, Kummampati, Professor and Dean, Academic CSE, NRA Institute of Technology, Agripalli, Dr. Neelesh Chandra Pikli, IIIT Nagpur, Dr. Pergusham, NIT Warangal, under Mr. D. Sai Sati, CEO, Indian Servers Vijayawada, and many other who bring with them immense domain expertise and research experience. I thank the guest of honor, Sri N. Lalita Prasad Garu, convener PB Siddhartha College of Arts and Science, for his encouragement and support in the execution of the program. I sincerely thank our principal, Dr. Maka Ramesh Garu, for his constant encouragement and unwavering support throughout the FDP. A special thanks to our director, Sri Vemuru Baburao Garu, whose vision and support played a key role in initiating and executing FDP successfully. I deeply obliged to Professor C. Rajesh Jampala, Dean Academics, PB Siddhartha College of Arts and Science, for his constant motivation and encouragement. I express my sincere gratitude to all the resource persons who invested their precious time and shared their expertise, which made the FDP more meaningful and impactful. My deep appreciation to the co-convener, Mr. G. Samrat Krishna, Assistant Professor, Department of Computer Science, PB Siddhartha College of Arts and Science, for offering technical assistance to ensure smooth execution of all sessions. I also appreciate Ms. K. Bhuvaneswari, Assistant Professor, Department of Computer Science, PB Siddhartha College of Arts and Science, for her dedicated support in handling the registration process, coordinating the online sessions, and assisting participants in resolving technical issues. My heartfelt thanks to the rapporteurs, Mrs. A. Kavita, Mrs. B. Roja Priscilla, Mr. D. Sri Naga Prasanna, Mr. B. Prashant, Ms. D. Datri Srivalli, Ms. Sheikh Parveena, Ms. C.H. Yogasri Rajalakshmi, and Ms. B. Harshita Reddy, Faculty Member, Department of Computer Science, PBC Siddhartha College of Arts and Science, for delightfully documenting and reporting each session. Last but not least, I thank all the faculty participants and research scholars from across the country for their active involvement and enthusiastic participation, who truly made this FDP interactive and enrichment. We had received 330 registrations across the India. On behalf of PB Siddhartha College of Arts and Science, I once again thank everyone who contributed to the success of this FDP. Wish you all the continued professional growth and many more opportunities to engage with the emerging technologies in future. With this, we formally bring this FDP to a close. Thank you and have a wonderful day ahead. Now I am handing the proceedings to Mr. G. Samrat Krishna.
A very good evening, everyone. It is my honor to deliver the valedictory address of the 6-day ATAL Faculty Development Program on Advanced Computing and its Application Trends, organized by the Department of Computer Science, PB Siddhartha College of Arts and Science, Vijayawada. Over the last 6 days, we have witnessed a series of enriching sessions delivered by eminent experts from academia and industry across the globe. Their insights into quantum computing, artificial intelligence, high-performance computing, cloud technologies, deep learning, parallel programming, and ethical considerations have really broadened our horizons. At this moment, I want to place on record our deepest gratitude to all the distinguished speakers. Your expertise, clarity, and commitment have been the backbone of this FDP. Each one of you has left us with valuable knowledge and inspiration that will guide us in our academic and professional pursuits. I sincerely thank AICTE Atal Academy for granting us this opportunity and extend my heartfelt thanks to our principal, Dr. M. Ramesh Garu, our director, Dr. Vemuri Baburao Garu, our dean, Professor Rajesh C. Jampala Garu, and the Siddhartha Academy management for their constant encouragement and support. A special word of thanks to Ms. K. Bhuneshwari for providing the technical assistance. And also, I would like to thank each and every faculty member of our department. A. Kavita ma'am, Assistant Professor. B. Roja Riskilla ma'am, Assistant Professor. Prashant, Assistant Professor. Harshita Reddy, Assistant Professor. Sai Prasanna, Assistant Professor. Srivalli, Assistant Professor. Parveena, Assistant Professor. Rajalakshmi, Assistant Professor. And each and everyone, word by word, I would like to sincerely thank and have my gratitude for supporting and for the smooth conduct of this faculty development program. Your dedication, teamwork, and support throughout these 6 days have been instrumental in ensuring the smooth and successful conduct of this FDP. Last but not least, I thank all the participants for your active engagement, interactions, and enthusiasm, which made every session lively and meaningful. As we conclude, let us carry forward the learnings from this FTP, apply them in our teaching, research, and innovation, and continue to explore the exciting future of advanced computing. Once again, my sincere thanks to the speakers, participants, and the department faculty, and everyone who contributed to this success. Thank you, one and all. By this, we formally conclude the 6 days online FDP on advanced computing and its application trends, organized by Department of Computer Science, Parvathaneni Brahmaya Siddhartha College of Arts and Science.
Samrat sir. Samrat sir.
Yes, sir.
Please inform about the assessment, sir.
Yes, sir. A small announcement to all the participants. The assessment will be started at 7:30 p.m. and you need to log in to your Atal portal. In the Atal portal, you will find a link like assessment on the left side menu. And when you click on the assessment, on the right side, you'll be able to see the link for the assessment. And when you click on it, you'll be redirected to a new page. And there you'll able to attempt to the assessment. And there are 6 questions which are formulated from all the presentations which were carried out during these 6 days. And the duration will be for 1 hour, and each question carries 2 marks. A minimum of 70% has to be secured by everyone to be eligible for the certificate, and 80% of attendance is mandatory. After the assessment is completed, you need to submit the feedback in the Atal portal only. Then automatically your certificate will be generated in the Atal portal within 5 to 10 minutes. So be very much cautious while submitting the examination. The examination cannot be reconducted. Once you had submitted, whatever the marks that you'll be secured, it will be your final marks. And once your assessment is submitted, even we can't do anything from our end. So at 7:30, the assessment will be started. And if you face any technical difficulties, you can reach us out through the WhatsApp link. Any queries, you can unmute yourself and you can ask them.
Bhavana, please keep feedback link in the group.
The assessment starts at 7:30, ma'am. Even though if you log in now, it just says that the assessment starts at 7:30. So you need to wait till 7:30 because we need to update the attendance of today sessions. So it will be taking approximately like an hour for us. So at sharp 7:30, you can log into your Atal portal and you can start the assessment.
Samrat garu.
Sir, చెప్పండి.
ఇక్కడ మీరు ఫీడ్బ్యాక్ అనేది మళ్ళీ అటల్లో కూడా ఇవ్వమంటున్నారండి. ఇక్కడ మీరు ఇచ్చే ఫీడ్బ్యాక్ వేరు, మళ్ళీ అటల్లో కూడా ఉంటుందా ఫీడ్బ్యాక్ ఇవ్వాలా?
అటల్ ఫీడ్బ్యాక్ సెపరేట్ గా ఉంటుంది సార్. అటల్ ఫీడ్బ్యాక్ ఇచ్చి అసెస్మెంట్ కంప్లీట్ చేస్తేనే మనకు సర్టిఫికేట్ వస్తుంది సార్.
అండ్ ఇప్పుడు అటల్ ఫీడ్బ్యాక్ క్లిక్ చేస్తే నో ఫీడ్బ్యాక్ అని ఉంది.
అంటే మీరు అసెస్మెంట్ కనుక కంప్లీట్ చేస్తే మీకు ఫీడ్బ్యాక్ వచ్చేస్తుంది సార్.
ఓకే. ఆఫ్టర్ కంప్లీటింగ్ ది అసెస్మెంట్ విల్ గెట్ ది ఫీడ్బ్యాక్ హియర్, అంతేగా?
ఎస్ సార్ ఎగ్జాక్ట్లీ.
మీరు ఇచ్చిన ఫీడ్బ్యాక్ ఫిల్ చేయాలి, అసెస్మెంట్ వాళ్ళ ఫీడ్బ్యాక్ కూడా కంప్లీట్ చేయాలి.
Yes, sir. Yes. I'll just log into my account and I'll show you, sir. If anyone needs, you can just have a look.
Okay.
So I hope my screen is visible to everyone.
I think some technical issue is there.
Yes,
while
sir. I'll address
Google.
everything. I hope everyone is able to view my screen. Here, if you look at the ATAL portal, on the left side menu, you can find something like assessment. Here at the bottom of the page, you can see the page called something like assessment here at the bottom below the attendance. And when you click on the assessment, you will be getting a list of the assessments which you can take. Yeah. So this is the assessment that is there for our FDP session. That is, the dates are specified here. That is from 1st September to 6th September. And here you are having a blue color type of link. And when you click on the link, automatically it will be redirected to this particular page where you'll be having all the instructions which you can see for taking the assessment. After clicking on this, I have read and understood the adhere to the assessment guidelines. And if you click on start, it will automatically get redirected. But as of now, as we had scheduled the assessment for 7:30, you can see the warning over here that you can take assessment at or after 7:30 on 6th September. So this is the procedure to take the assessment. And after the assessment is completed, you need to fill the feedback in the ATAL portal itself, and the feedback will be available after the assessment has been completed. After this particular feedback and the assessment both are completed, then you will get a certificate here at the bottom of the page itself. If you click over here, you will be seeing what all the FDPs that you had attended, and here the certificate will be generated automatically. There is nothing that we can do from our end. Everything is automated and everything will be done as per the timings. So any queries, you can unmute yourself or else you can post in the chat box. Yes, the assessment starts at 7:30 sharp. After 7:30 or at 7:30 sharp, you can log into your ATAL portal and you can take the assessment. Yes, assessment will be through ATAL portal only. We are not providing any separate Google link or something like that. The assessment will be for 50 MCQs, where the questions are at a moderate level, where everyone can can answer easily. You'll be having 50 MCQs. That's it. The closure time is like within 1 or 2 hours from the starting of the examination. Like exactly we had scheduled for 7:30, and by 8:30 you can take the assessment at any particular point of time. Yeah, the assessment lasts for 60 minutes after you start the examination, and you can start from 7:30 to 8:30. That is the time which the assessment link will be active. Yeah, you can leave the meeting if you are done and if you are very much clear about everything, you can leave the meeting. Yeah, any queries you can kindly post in the chat box, or else you can reach out us in the WhatsApp. Our group will be open for until your assessment will gets completed till 8:30, where everyone can post your messages. Yes, you need to take the exam. I mean, like you will have 60 minutes of time to complete the examination. Yeah, I'm repeating the procedure again. If anyone are having any doubts, you can just have a look at it. After you log into your ATAL portal, there is a link where I had placed my mouse cursor. Yeah, here you can see something like assessment. And once you click on the assessment, that is which is below the attendance and above the feedback, once you click on the assessment, you will come across with all the examinations which are available. So the above examinations were the previous one which I had attempted. This is the one which we are attending now. That is from 1st September to 6th September. And beside that, you are having something like a test link, the one in which is in the blue color. And if you click on the test link, you'll be redirected to a new page. And here you need to accept the terms and just click start on the examination, and your examination starts. And you will be having a time of 60 minutes, 1 hour to complete 50 questions, which all are MCQs. And kindly be sure that you will be scoring 70% in the attendance, in the assessment, because once your assessment marks are submitted, we cannot change, and you will be eligible only whenever you secure a minimum of 70 marks, 70% of the marks in the assessment, and 80% of attendance throughout the 6 days. Yes, if you are comfortable, you can complete the assessment through phone. But I prefer, I suggest completing it in laptop, which will be very much flexible for you. Feedback link is already posted in, for attendance purpose, feedback link is already posted. I'll just send it again. You can fill it. Yes, you can send the chat in, the message in WhatsApp. Today we'll enable for all the participants so that we'll be able to address all your queries. We'll open the chat box in WhatsApp from 7:30 onwards till 8:30. You'll have 1 hour of time. Any queries or any technical difficulties or else any technical glitches, you can contact us and we'll try to resolve as early as possible. Yeah, participants can leave the session now.